Done. Started.
Okay.
Awesome. Okay. So the left hand side can be taken as, so let's first write the inputs, right? Input
H and S. Sorry.
H.
Let's.
Yeah, H and S works. Small h and small h s works. It's fine. So if the input is H and S, happy is nothing but
0.3h plus 0.5s.
Right.
exactly.
Should I write?
So, yeah,
Yeah,
you can write it
down.
in 0.3 H.
0.5 of s.
Right.
Yeah.
And stress is 0.7 of h plus 0.5 of stress itself minus 0.5 of stress.
Think about it. 0.7 of
Okay.
H.
Stress is being half, so it will be only 0.5.
Right.
At any point, you're just incoming is 0.7 of H, and what is staying is 0.5 of what was already at S, right?
Okay, we are.
So
Actually, if you want to just
to me?
verify, we can just check that when we add both of them, you get H plus S, right?
Yeah.
So
But
the
that
H plus and S should be 1.
Itself be 1000 now. H plus S is equal to 1000. We can say.
Yeah, we can always verify that way, is because total number of people should always be 1000, right?
We can
In our
Exactly.
quest.
the third equation itself. H plus S is equal to 1000 because we are given 1000 peoples. So there's some.
So H plus S is
So
equal
here
to
it will be 1, right? Not 1000. Correct me if I'm wrong.
no H. What is H plus S? H is the number of people who are in state H, happy, and
Okay.
S is the number of people who are in state stressed at any given point. That will be equal to the total number of people, right?
Yeah.
Right? No matter if they move, they either have to be in stressed or happy. That's what we're trying to say. Right? So now we can see two
Simultaneous equations.
simultaneous equations.
Should I write these two equations in a matrix form?
What is it equal to? What is the right hand side? So 0.3 H plus 0.5 S is equal to what? And 0.7 H plus
People who are
0.5 S
happy.
is equal to what?
So this is not small h plus s. It's capital. Okay. So people who are happy and people who are stressed. So that's 1000. So people who are happy initially are 1000. So h is 1000 initially.
Yeah.
And s is 0.
Yeah.
So 0.3 of h plus 0.5 of s equals
300.
But
So what if
how
we
do we
substitute?
Yeah, go ahead, Pranit.
What if we substitute this part of the equation in this happy people, like 0.7
Still
of,
don't have a right hand side, right? So we
Yeah,
can't equate
exactly.
it to anything.
okay.
But we know 0.3 H plus 0.5 S. Okay, that will just become 1 of H plus 1 of S is equal to 1000. Right? What else can we do? The input changes.
Our input.
Correct. This like reminds me of that. Like I don't know if you know, like when you have two plates that are like different temperatures. it eventually gets to a state when both are equal, right?
Exactly,
Equilibrium.
exactly.
Yeah. So if we think of it in that way, then we can equate both to 500. But I'm not sure that's
No,
this.
I don't think we can do it to 500.
Something different.
I mean, what we eventually want to find out is
The distribution, but I don't. If it
exactly.
wasn't, I think if it was a 0.5, like everything was 0.5,
Yeah, yeah.
I think eventually it would reach that. Yeah.
What if we can include this
Yeah,
h is equal to 1000 in some another way, like just writing a matrix 0.3, 0.5,
Yes,
0.7,
yes,
0.5
yes.
as h.
Can everyone else see that? Can they see that you can write these two equations as a matrix first?
that's the equation without.
Yeah.
Okay.
No, just we are just writing ax, not b for now,
Yeah,
because
yeah, yeah.
b.
Only the left hand side. Can we write the matrix once, maybe?
Mm.
3, yeah.
0.7,
Mm-hmm.
0.5 and 0.5.
That's something we know.
Is this correct?
0.3, or it should be 0.3, 0.5.
0.3, 0.5, 0.7,
Yeah.
0.5.
Yeah,
You
row
understand?
wise.
Row wise.
Yeah.
0.3, 0.5.
Yeah, I made a mistake. I
Sure,
was
sure.
trying to write in the form of 0.3 HM.
Yeah.
Mhm. Now it's correct.
This when multiplied by the input h,
A and
h and
H.
s.
Yeah, HNS. HNS. Yes.
Can we write s as 1000 minus h?
S. Yeah, we can. 1000 minus H. Is it
Here I
stuck or
have
okay?
an
Okay.
idea, like
Mhm.
doing
Why
something.
can't we take h plus s equal to 1000 as a third equation and fit that into the matrix too? I mean,
So that
is
will
that
be, yeah, but we don't know the right hand side of the first two equations anyways. So how does it help knowing, say we write the third row as 1 comma 1 and the right
like
hand side is 1000.
what I was thinking is that anyway we're supposed to get we'll
I
only
have an
get
idea.
integers on the uh, b, right? Ax equal to b, we'll only get integers on the right hand side, right? So can we
Mhm.
find a solution in that way?
Mhm.
Yeah,
Okay.
can you write 4, 5 in a transpose as a transpose? Just
What?
write it. 4,
4 and
5,
5.
5. Sorry, this is HS. Sorry, HS as a transpose. uh,
Okay. But
HS,
why?
yeah, in a row form.
Okay. Can you write h and s as a row? Row, yeah, row vector. Yeah.
And
Okay.
a matrix of a vector, a column vector at right side, which is 1 1.
Sorry,
Okay.
A vector at in right side that has values 1 1
Yeah.
1 and
Equals
1.
to 1000.
1 1.
Yeah. This is the same as writing 1 1 as a row and HS as a column, right? Which is
Yeah,
nothing but adding the third column in that matrix.
and this will
Sorry,
be equal to,
third row.
Equal to 1000.
we need to now modify our a in such a manner that this thing is satisfied, because
Yeah.
it is
So,
just their multiplication is just h plus s.
Okay,
yeah, yeah,
okay.
yeah.
So
So,
so this is equal to 0.3, 0.7 as matrix multiplied with HS, right? So we
Yeah,
can
yes.
we
So
can
we
keep
can
it.
write this on the right
Hmm,
hand side, is it?
yeah. Yeah, we can, I think.
so now the
No,
question,
but
how we can we accommodate a somehow?
I didn't get that. Like, what did you mean?
I just wrote the equation h plus s is equal to 1000, nothing else. Just see, it is h times 1 plus s times 1 is equal to 1000.
Yeah. I got the metrics, but after that, you guys said something, right? I didn't catch that.
That I'm saying, now we need to think that is there a way to accommodate this a, that is 0.3, 1 matrix somehow.
Hmm.
Okay.
So we know one thing. Even if we don't know what's the right side, we know it's something going to be 2 comma 1, right? Something that will be in the form 2 comma 1.
What is a
Mm.
times b ka whole transpose?
Transpose.
Can you write that?
What's a you mean
May
0 point?
Yeah, just name the matrices for now, so that it is a bit easier.
A and
A,
you mean
this
B.
treat this as b.
If
Yeah,
you just want to write HS11 equal to 1000 column form, that's not that difficult, right? You just have to.
we're just
That will
thinking.
become the third row. That will become the third row of the matrix. Did you get that, Maria? If I write the third row of the matrix as 1, 1,
But if we do that, we don't have the b, that is the
yeah,
s-
I
values
was
at the
thinking,
outside.
yeah, like we don't have the B, but we know that it's an integer. So can we solve it using that?
What I
And we
was
know
thinking,
like what I actually remembered. I don't know if this works. Like this reminded me of something. Like is it something using Cramer's rule? Because when you have one side, maybe you can use that.
okay. Can I,
So
can
Cramer's
I,
rule means yeah. Oh, no, I don't think you
yeah,
can.
yeah.
Sorry.
No. Let me just, I'll try to write the first equation itself in a form that all of you are trying to write it, right? I won't add a new row. Instead, what I will do, can you zoom in on the matrix once? The matrix on the top right, yeah. So, can you say equal to? Can you, no, can you give a space a little bit on the left and then write AB as a
just rename this hs vector as x. That
yeah, that's fine. Yeah. So is equal to AB, right? It's this will give us an output AB, just a
Okay.
vector AB. Okay. Mm, we know if I write a row vector to the left of this 1, 1 to the left of AB. Actually, that's why I wanted little space. Did you understand? Praneeth, right?
Yeah.
Is there a
Praneeth,
way to select all of this and move to the right? Can you see?
that's fine. No. Can you just remove that equal to sign?
Okay.
We can put the equal to sign later. Can you put a row vector of 1, 1 next to AB,
Okay.
next to AB, like close to AB?
On
No.
the left
B,
side.
yeah. This is equal to 1000, right? This vector multiplication is equal to 1000, right?
Yeah.
I mean, I'm just trying to write the entire thing that you've written separately in one line. Maybe the left hand side is not equal to the right hand side. The left hand side is equal to AB, and when that AB is multiplied with
Hmm.
the 1 vector, it gives us 1000. This is giving us all the information we know, right?
So here, this A and B is same as this A and B.
No. Sorry. Can you?
That was I was saying that rename that.
Okay. Can you? Yeah. Maybe call it
M and N.
M and N. Yeah. So this is the output of the matrix with the input H and S.
Okay.
And we know the total number of people will still be 1000. That's all I'm trying to say. So we have a restriction for that. Another way of writing this as a single matrix would be to add a third row to matrix A as 1 1 1.
But in that case, we don't know the first two values of the B vector.
Yeah, we can
Because
just keep it as M, N, and 1000, right?
but now we will have four variables to solve to look at.
No, we still have only two variables. How did the variables change? Remember, I'm adding a row. I'm not adding a column. Column will increase variable.
1, 2. You have one here.
It's like saying we have three equations and only two variables.
No, what I was saying is, if you write B at the right side, then you don't know that what you have to fill the at the first and second position. Third, you know
Oh, you
that
mean M and N?
yeah,
That we already have, right? Now also we have four variables, right? HS and MN are still there.
yeah.
So four variables stay four variables. I'm
Mhm.
just representing the third one. So okay, let's not talk about representation too much. Let's try to focus on how do we find out what HS. So okay, 1000 is the first input. H is equal to 1000, S is equal to 0. We just have to iteratively apply
Change
this
H and
function
S.
on 1000, right? That's all,
Hmm.
right? That will give us the answer, isn't it?
Good.
I mean, that is what we could
When
have
do
done
we
from the
stop
start.
actually?
We can stop at, let's say, um, okay, we can stop at 1000 iterations. That can be just a random number we can think of. Or we can try to store the previous value of H and now the current value of H and see if the difference is not too much.
Yeah,
So that means it's not changed too
it's
much, right?
stabilized. It has stabilized to a point.
Exactly. So do you want to write a code for that? I think that's the only thing we can do
Yeah.
now.
Praneeth, can you
You,
share Replit or
So,
something?
small
Let's
demonstration,
do it.
silent
yeah.
demonstration is
Sorry, did anyone get what sir said? I couldn't catch.
I'll give you people a silent demonstration on
Okay.
Google Sheet. Okay.
Okay,
Yeah. Just watch.
sure.
Can someone tell me the matrix?
So it
So
was point
point
P. Oh, okay. LB2.
Okay, someone should whistle now.
They are just closing into this. 625 and 6.
If you try varying anything on DE, that the sum is 1000, it still gives the same two numbers at the end. You can try varying. I'll give access to you people. Maybe you can type your Chetan, maybe your email, or wait, I'll post the link. Yeah, come and change the entries of B2 and E2, and you will observe that the convergence to 625 and 374 is constant. The best part about this is you can even consider changing the matrix 0.7, 0.3, 0.5, 0.5, which means that you're changing the 2 coins bias, right? So beautifully, it's converging. See the property and decode this. I mean, this is one example of probability in linear algebra that is so applied that there cannot be more interesting a topic than this, in my opinion. Why has it become something else, sir? 1000 and 0 should become always 625, 375 only. I think they have changed the matrix. Let me check.
Yes, sir. With it was 0.3, 0.5, and 0.7, 0.5. So I just updated the A1 A column, A1 and A2.
Even you changed, is it?
Yeah, it was. I just reverted
Right,
the
right,
values
right.
of A1 and A2.
Okay, perfect. No problem, no problem. I was just wondering why this. Now you vary D2 and E2, it will still be the same. उसको 500 500 करो D2 E2. See, it doesn't change. The final value doesn't change. It still is 416 and 583.
That is like a balance point between both the things.
When the starting state, it depends on the ratio to its the probability.
Okay, it will converge very slowly if you put 0.1 and 0.9. In both the places. Change 0.5, 0.5 also to 0.1, 0.9.
So first is where it's 0.5, 0.5, and this take one step.
Okay, sorry. Make it 0.01 and 0.99. One moment.
So if we make both the vectors same, it's basically collapsing to a line, right? In that case.
What's the error? Can someone fix the error? I
Yes,
think
sir.
you included something. It was nothing to do with the numbers there. It was something to do with the formula here.
Ben, sir.
See, in this example, it's not converging quickly. Which means you should do a little more. See, again, not converging, right? But 100,000 iteration, it will converge. Go down and check, it's converging to half and half.
Yes, sir.
Is that if the rates are same, like if the flow is same from happy to stress, then converges to 500.
Pardon? I'm so sorry,
Like if
my
it's called,
my
yeah,
little
yeah,
son is singing here. I'm so sorry. Go on.
yeah. Like if the first column vector and the second column vector are same, like, are the same, like then it converges to 500. So
If the first column vector and the second column vector are the same,
it converges to 500.
does it?
Yeah,
It's the
yeah. Like
same, right? The column vectors are same. Okay, it's not same.
no,
So
no, no. Now it's not same. Now it's not same.
you mean 0.01. You mean this, right?
Mm.
Okay, so now initially we have 0 and 1000. Okay, yeah, it does.
It's very similar to what you discussed first, like Maria. You said, what if both are 0.5, 0.5, 0.5, 0.5?
Yeah,
Hmm.
yeah.
Hmm.
Guys, there's some problem with the formula. Just give me a minute. I'll fix it. I don't think this is doing matrix multiplication properly. Just check. You're taking A1 and B2. You should take A1 and B1. Right? Look at the formula in D3. Can someone please fix it? Or wait a minute, I'll fix it. Yeah, now it's perfect. This matrix will always go to half and half. Always. And the reason is so intuitive if you see it geometrically. But anyways, that will be for module 3. But for now, you figure out why this is converging by hook or crook. See, it takes a long time to converge. But if you put 0.7, 0.3 answer, whatever the previous one, it converges so fast. Let me. Yeah, just play around with this matrix. I'm sorry, the previous one was incorrect. Just ensure that you put the right thing and then you carry on. More interesting would be the 3x3 case. Anyway, so 2x2, if you crack, you know everything about this property. In fact, this is a great motivation to understand eigenvalues and eigenvectors too. Anyways, don't break your head. Don't try to forcefully bring that idea. Just play around with this 2x2 matrix. That's all.
The columns have to add up to 1, right?
That's right. That's the model, right, of that happy stressed problem.
Yeah.
This is like passing the input, that is output of function to itself around
Hmm.
till the output itself is converging
Right.
again. Like we're just multiplying a matrix again and again with the
That's why there was no right hand side because our H and S were the right hand side as well at the same time,
Mhm.
right? That's why we didn't find it was hard to figure out what was the right hand side for the matrix because whatever the output was, that was the input for the same matrix again.
Mhm.
Hmm.
I think the ending condition would be such that the input that you give to the matrix, like because sir mentioned eigenvalues, like that's what I remembered. That the when you give the input to the matrix, you'll get the same vector.
Sorry, can you repeat that?
Uh, when it converges, it's such that when we apply that function to the vector, we get that vector itself, right? That is eigenvalue is 1, I guess. Yeah.
Okay.
But here the output is again and again changing till the
No,
iterations are
no.
not.
When it converges, the output and the input will be same, right? Because at
Yeah,
the end,
the
Hmm.
converging.
so I think I don't know how, but the eventually the question is I think you have to find the
The
okay, no, I didn't think through. Yeah,
Can we look at a easy matrix first, and then we'll try to think about it. So, what happens to the matrix when the matrix 1001 is applied uh, to any vector?
It remains the same.
Okay. What if so? What is it potentially doing?
it's giving you a scaled version of the
same
vector.
thing.
Yeah,
He
the
is
same
saying
thing.
when we are multiplying with an identity matrix, then what is identity matrix doing with that?
You're scaling the I and J by 1. So you're essentially getting the same thing again.
No, we are not scaling. We are just selecting one column vector from a set.
No,
So
when
altogether,
you multiply the vector, what you get is a scaled up version of the vector, right?
yep. Internally,
That's the definition of eigenvalue. Yeah, I just said that. Yeah, that was kind of useful.
oh no, he was asking for identity when the matrix is 1 0 and 0 1.
Yeah,
So
yeah.
the
1011 is an easy way to understand it. Yeah, you get the same vector. Yeah.
So what you're doing essentially is first column scaling it by 1 in the I direction or X direction, and the second column scaling it in the Y direction with 1. So essentially, you're ending up with the same matrix.
Mm.
Okay.
So
But is your mic working now?
Yeah. I think there's some issue after like 5-6 seconds. It's like disconnecting. I'll try to see how long it works. Okay, so what was being discussed? Sorry.
1001 matrix.
Okay, so 1001 given any vector is taking it to itself, right?
Identity.
But this is not the case for that's a special matrix, right?
Mhm.
Because every point is being mapped to itself.
I think we should close the video because his internet speed is not strong. That might decrease the load.
Earphones. It's an earphone problem, I think. No, we can't hear you. We
it's
can't hear you.
audible.
No, it's audible.
Is no, it's no. We were talking about Shrivinay.
Okay.
Yeah, I mean, if you're saying that, yeah, we can hear him. Yeah, we can hear him. We can only hear this.
Okay. Guys, just share this Discord IDs so that we can at least message each another. Like today, some of us were late and we were trying to get contact with the rest of us.
Yeah, I I think I put my ID into chat box earlier. Let me do it again.
Let's add each another. Tell them.
That's fine.
Can you hear me now? Please tell
Yeah,
me
yeah,
yes.
yeah, yeah, yeah. We can hear you.
Okay. This headphone is a little. The left hand side doesn't even work. Only the right hand side works. So it's a little disorienting, but it's okay. Yeah. So for the matrix 1001, every point is being mapped to itself, right?
Right.
But if we change the matrix even a little bit,
We're going to get a different value.
we're gonna each point is being mapped to a different point.
Right.
Now the question arises: is there a point that given any matrix, right? Given a matrix, is there a specific point related to that matrix, specific to that matrix, that is being mapped to itself in the output realm, right? That's what this kind of means, right?
Yeah, that's what it means. Yeah.
Because if inputting whatever the output is, and at some point the input is being equal to the output.
When it has the board, like you can just write it down, I guess. Like
Sure, sure.
Yeah, just
do this
right.
equation.
I joined on my laptop for that only actually. I hope I can start annotating things. That'll be better. So whiteboard is available. Do you want to go with that, or do you want me to just maybe?
We
Let's
can
go
get
into
the
it.
PDF. Yeah, we can get
Yeah,
the
go.
PDF of the whiteboard, right?
Yeah. Okay. Can you see the screen? Is
Yeah,
this the
yeah,
same whiteboard that we had before? It looks a little different to me. Okay, I
I'm just
was
staying
I
with
was on my phone. So, are you guys able to write anything? I just want to check. Yeah, yeah. Okay, cool. All right.
Recording in progress.
My bad.
that was I switching my device.
Okay, no worries. How do I hide this? Hide video. Okay, that's video panel. Hide floating meet controls. Awesome. Okay, and okay. This concept is actually quite difficult for me to explain, but let's try. Okay, I'm not able to write on the board, is it? God, I'm using this for the first time. Sorry if. Did the whiteboard close by any chance?
Yeah,
It's
not.
not visible to me.
Okay.
Okay, let me start a whiteboard. Okay, is it visible now? Yeah, go
Yeah.
ahead. Yeah, go ahead. Write on it. We can export it.
This is the whiteboard we usually use, right? This was
Yeah.
a little different. Sign in now to avoid losing access to this whiteboard after the meeting. So should I sign in now?
I mean, I think we can export it, right? So you can just use it. We can export the PDF, it in PDF form.
Okay. I just want to check that one. So where do I export it?
So
Yeah, that's export.
you
Yeah.
have this more, right? The more
Yeah.
and go to exports. You can export it.
Found it. Perfect. Okay. So I can, okay, where are we?
Just click on that I button in the top right corner so that you can invite everyone. So
I button in the top right corner. Okay, I button. Collaborators in the same meeting. There's no other I button. Is
I.
oh, the I. Yeah. So
Yeah,
invite all to follow me. That's the button,
right,
right?
right.
Awesome. Okay. Yeah. Uh,
Yeah, it's visible. Perfect.
perfect. So we looked at a matrix. Say, let's use our usual matrix. 1, 2, 3, 4. Even though I'm using a mouse, I'm very bad at writing things down, so don't mind it. So is it true that this matrix also has a point that it maps to itself? What is this matrix doing?
Only this.
Yes, whoever said 0, 0, you're right? Only 0, 0 will be mapped to 0, 0, right? Because in this, we are taking x plus 2y, like we're taking, I mean, sums of two integers, right? And potentially, this matrix is just pushing things away from the center, if you think about it in that way.
Mm.
And I mean, it's no point will like be mapped to itself in this case. But what was special about our matrix before? What was special about the matrix before that made sure that there was some input
Mm.
for which the output was the same? What was that property?
Identity matrix. Are we talking about identity matrix?
No, I'm not talking about identity
Okay.
matrix. I'm talking about, we saw a few iterations
Mhm.
of some matrices, right? There was a peculiar
Mhm.
property about the columns of those matrices. Remember? So what did the first column actually represent? Something that adds up. It was actually representing the probability of happy, right? I mean,
Probability of happiness.
like probability of being in happy or probability of moving to happy. So, no,
Being in happy. Being in happy.
yeah, being in happy and moving out of happy,
Mhm.
right? So the sum was always equal to
1.
1.
1, right? So we had say 0.3 and 0.7
Mm. 0.5, 0.5.
and 0.5, yeah. So this property of matrix was helping us understand that if we keep, uh, inputting the output of the previous iteration to the input, we kind of, reach a, what do you call, stagnant point? How do you want to call it?
Equilibrium point.
Yeah,
Let's
equilibrium.
call it.
That's, yeah, we'll stop. We end up at a equilibrium. Is that equilibrium?
Just call it equilibrium. That's
Yeah, equilibrium, right? I think I'm totally wrong, but that's okay.
let's call it
Equilibrium.
EQ point. Let's call
Perfect,
call it
perfect.
EQ.
EQ point. Yeah. So this property of a matrix was what showed that there was some input for which the equilibrium is reached, right? So, I mean, these matrices are different from all the other matrices you've seen. This is a different matrix, and because of the property of this matrix happening to be in such a case that the columns all actually represent a kind of probability or like a sum up to 1, it has this equilibrium point. This is also true for the case, I mean, this 1001 also happens to be the case of that, right? I mean, the sum of this column is 1 and sum of this column is 1. So this is like the general case, right? Where the first column, I mean, the columns sum up to 1, and this is one specific case that we study, especially because it maps the I vector to I and j vector to j, and every point it actually maps to itself. I'm actually not sure. I mean, how to move from here to eigenvectors. I don't know if the connection that Sir mentioned is easy to access, and it's not. I don't see it clearly over here, but maybe a few other ways that we can understand eigenvectors and eigenvalues can be discussed. Does anyone want to take a hit on how this might, what this might say of a matrix, what this might represent of a matrix, what we can maybe, such matrices, can we show other matrices in this form, or is there always a form of matrix that maybe comes out? Because eigenvectors are there for all matrices, right? If I'm not wrong.
Yeah.
Yeah, it'll take some effort.
Uh,
Okay, maybe
More-
we'll not focus on eigenvectors. Maybe we'll try to see, I mean, what is the problem we're trying to solve? Can someone try to think of what is the problem we want to solve? Maybe state it.
After we give some input, it should give you the input itself, right? So that's when we converge. That is, we apply the input to the matrix, which is a function, and you get the same vector again. Then it converges, right?
Yeah. So maybe the question can be, how do you find the input for a given matrix which is of this form? How do you find the inputs which are being mapped to itself, right? That can be a question we can write down. Maybe I'll write it down as well. Find x comma y, which are inputs that map to itself. Given such a matrix. Given such a matrix, right? Let's start. So again, I always try to write the same matrix in different ways and try to understand how different view can help us. Maybe 0.3 and 0.7 of x plus 0.5 and 0.5 of y should be equal to xy. Right? This is what we want.
But this matrix, that is coefficient matrix of 0.3, 0.5, 0.7, 0.5, has to be multiplied repeatedly.
Yeah,
So
but in the end, there is some xy which are inputting, for which xy itself is the answer, right?
yeah,
So-
but for that the coefficient, the column vector should have changed after n number of multiplications, now.
Yeah, only these two are changing, right? So if they're changing, when they stop, that is still some particular x comma y, right? It is not like it depends. I mean, it doesn't in the process, it does depend on the previous output, right? But in the end, you are just applying the matrix on a particular input. Okay. Hi, Nishan. Yeah. So
Hi, Srivana.
hi.
Okay. Just let's just show that question once again.
Yeah.
Nishanur and Ashik just joined.
Yeah.
So
It would be better if we summarize. I mean, just
Yeah,
2-3 minutes. No, thank you.
Sure. You want me to draw the question over here? Or maybe copy paste. Can I copy paste it here?
oh, you can share your screen. You can share your screen. Do
Like
you have
we
that?
already did that. I think Praneeth has that, like the board, right? We can just show that.
Yeah, I
We
think I need to
already.
stop presenting for him to start presenting. So is that
Should
okay?
Just a
use it.
second. Let me just export this first.
Or just show them link the send them the link of the website. Remember the website, right? The module 1 and module 2. We're actually discussing the 6th question of module 2, I guess. A new figure that sir has drawn. Maybe I can even draw it here. It's not too hard. So there are two states. I'm drawing it here. There is, okay. I lost this whiteboard. Anyways,
So let me share the screen.
sure.
Share the question itself. Okay, the screen is visible, right?
Yep.
Okay, so this is
I was type pasting this question, a screenshot of the question, and that the whiteboard just vanished because I don't know why.
Okay, so this is the question, right?
Coincidence.
Yeah,
So
this is the question.
this is the question. So we have two states, happy and stressed here, and we are starting with 1,000 people. Okay, so 1,000 people will start in one of these states, either happy or stressed, and we have to find out the distribution after a number of iterations. After a while, what would the distribution look like? So you can see that if you have 1,000 people in happy states in the beginning, in the next step you have 300 people as happy and 700 people as stressed in the next step. Step. If you start with 1,000 people as happy, so 0.3 of 1,000 remain happy, and 0.7 of them become stressed. So that's 700 people becoming stressed. So once you come to that point, in the next point, what you're actually doing is you have 300 people who are happy. Now 0.3 of them will remain happy. That is 90 will remain happy, but 210 will become stressed. But the stress already there were 700 people as stressed. 0.5 of them will remain stressed, and 0.5 of them will move to being happy. So that's 350 will remain stressed, and 350 will become happy again. So that's for happy, that's 350 plus 90, and for stress, that's 350 plus 210 from the happy. So that's the third step. So what we are seeing essentially is for the happy, we have 0.5 of stress plus 0.3 of happy. And for stress, we have 0.7 of 0.5 of stress plus 0.7 of happy. So we have two equations. We were discussing those two equations, and we also noticed using the Excel sheet that they're conversion after a point. So we had point
No,
five.
wait. Before that,
Mhm.
Nishan, do you understand the question? Let's
Yeah, go ahead.
give a pause.
I guess there is an iteration going on that there is a 100% happy person in a room, and then 0.7 of them, 70% of them becomes stressed, while 30% of them remains happy. And what happens with this stressed person is that 50% of them remain stressed, and 50% of them becomes happy back again. So it was 0.7, so 50% is 35 plus 30, that is 65 are happy now. And from that 65, and again 70% would become stressed.
Not 65. Not 65. It will change. See, the change will happen in both the places, happy and stress at the same time.
Okay.
In the starting, in the beginning, you only had happy as 100%, but stress was 0%. But in the next step, you have some value of stress and you have some value of happy.
Okay.
So in the next step to that, both the values will change simultaneously. So you have to keep track of it.
So in second case, we'll start keep tracking of both.
Okay, Praneeth, do you have that Zite board open?
Yeah,
Do you
yeah.
have this? Okay, let me stop sharing. Can you share that Zite board again? Can you show those iteration that we did? Yeah. So see, in the first step, we started with the 1,000 people as happy, right?
Let him go through it. Maybe he can tell us
Yeah,
if
right.
what we're doing is right, or maybe
Mhm.
somewhere we're going wrong. So
Right.
let's go. Iteration 1 is the top left. There are 1,000 people in happy and 0 in stressed. Iteration 2 is below it.
Okay.
Yeah.
So 30% of 300 remains happy, and 70% of happy becomes 70% of 300 becomes stressed. Around 210 people. Fine. And we're okay. And for the next cycle, we'll count 50% of 7, and that is 350. Okay, but fine. What about the okay? Done with second step. The second step, this was all. 30% of 300 remains. Fine. And 50% of 700 gets added. That is 350 gets added. That is 90 plus 350. Okay, done with happy. Now we have to deal with stressed. 700, 50% of 700, that is 350 remains stressed, while 70% of 300, 70% of 300 become stressed. Okay, fine, 210 is added.
Now, yeah, so you understood the 3 iterations, right?
Fine.
Now we can move on. Yeah. Go ahead, Chetan. You can go ahead.
Yeah, so after that, what we did, okay, let me share the screen. Yeah, so we wrote those coefficients. So you understood that we have two equations, right? one equation is 0.5 of stressed plus 0.3 of happy,
Happy.
right? Then the second iteration is, second equation is 0.5 of stress and 0.7 of happy, right? The second
Vice
one,
vice versa, na, is it? It is.
no,
Yeah,
not vice,
yeah, why
not
don't we write it down? Nishan, you tell us what are the two equations for happy? What is the equation, and for stressed, what is the equation?
Yeah, let me share the.
Happy, it is 0.3 and 0.5 of stressed. 0.3 of happy plus 0.5 of stressed.
Perfect. Yeah.
For stressed, it is 0.5 of stressed plus 0.7 of happy.
Yeah. So now you've got two equations,
Right?
right?
Yes.
Can you write that as a matrix?
Yes, why not? Straightforward.
Yeah.
we
So
had
just take the
0.3.
coefficients. Yeah.
Just coefficients are the matrices. And x and y is x is happy and y is stressed, isn't it?
Perfect. Yeah.
And that equals, by the way,
No,
1000.
no. Yeah. So that is the thing.
No, not 1000.
It doesn't equal 1000. We just know there are 1000 people. So we know number of people who are happy plus number of people who are stressed is equal to 1000.
Fine.
Right? Now, now we'll try to put 1000 people as like we'll try to input few values to this matrix. What will it do? It'll move people around, right? It'll move 0.3 of the, I mean, it'll keep 0.3 of the people in happy and add that with 0.7 people from stressed. And it'll, in the stressed bubble, it will keep 0.5% of stressed and also add the 0.7% of happy. So if I apply this matrix on any input, right, it's like saying there are 1000. So the input, let's say we're restricting it to 1000 people. So it is a combination of x and y where x plus y is 1000.
Fine.
Right? If I start with 1000 people as happy and 0 people as stressed, right? That is nothing but showing, can you highlight D2 and E2? Do you see that? D2 and E2, D2 and E2, just above that, 1001, 1000, right? So that is like I'm inputting that, right? Now the next row is representing how many people will stay happy. You know 300 will stay happy, right?
Fine.
And 700 will become stressed.
Fine.
Right? So we are just trying to, so what are we doing? We're applying the matrix on whatever inputs keep changing in the bubbles. Right? Now we're trying to see what if we keep doing this? Will the number keep increasing and decreasing? Like, will it change a lot or will it reach a state of equilibrium?
Okay.
So this is the number of iterations and this is what we observe. What do you observe from this?
After 10, 11 iterations, numbers are converging. I mean, the equilibrium is achieved or reached, whatever we call it.
Yeah, exactly.
We're converging to a point. So now we are trying to figure out why it's happening. So that was the discussion that was going on when you guys joined.
Yeah, I think we're trying to find out not exactly why. We're trying to find out how do we. So now we know that if a matrix which has columns as a probability, which is nothing but saying the sum of the column values sum to 1. And that was
One second.
Yeah.
There is a thought that is coming to my mind.
Sure.
A very natural thought.
Mhm.
There was a question in mathematics 1 we read fine. Question of interest. Whether we distribute interest over infinite. I mean, should we calculate interest, daily or monthly? And it affects the total interest that we eventually at the end of the day get. There was this question, fine. And that was related to limit, I guess. Maths 2, I don't remember. This is a question of limit, I guess so. So is there I see that was that thing was also converging to a point where the interest initially the values were varying. Like if we were calculating the interest for a period of I mean half yearly, we were just summing up the interest and giving it away, adding up with the principal, and then again some calculating interest for the next 6 months, and then we did it for 4 months and then 3 months and monthly eventually. So okay, so that was the question. That was also converging after when we reduced the number of months, to 3 or 4, something like that, or monthly. I don't remember. The amount was getting converged, and it was showing no profit afterwards. Fine. So this is also kind of similar thing where an operation is going on, event is going on, some kind of iteration is going on, and then we are reaching some equilibrium point. So is
Yeah.
there some similarity?
I mean,
I
yeah,
mean,
the way you're saying it, maybe yes, I can see it happening.
I mean to say that, I don't remember whether this question was of limit or which topic. I mean to say is that at that point of time, matrices was definitely not the topic, or that was not a question of linear algebra. So that is to say that that question could also be solved via matrices.
Maybe, I'm not sure.
Said it's something related to probability too. Like there's some statistical idea in this too.
Definitely. There's definitely, I mean, applications in probability, definitely. Because if we take, now we can model a probability in such a case, right? We're able to model a probability function in such a case. We took the question of how many people stay happy and how many people stay stressed. If I just ask you, okay, on average, in the end, how many people do stay happy and how many people do stay stressed? You have the answer now. The answer is 416 and some 583, right? Yeah, sorry.
Here we practically show that the series, these values are converging. But before iterating, how can we ensure like we are using the metric operations calculating that a matrix times x is equal to x? In that case, how can we ensure that in certain cases it will always converge?
That is to say that Ankit is saying is that how do we generalize this? Fine.
Yeah.
How do
The
we
generalization-
generalize?
We
Yeah,
don't know
generalization-
the reason it's converging.
But we know if the matrix is of the form such that it's
matrix
kind of no,
I
it's
mean, this question we know that okay, sir has given this question in under the topic of matrices and linear algebra. That's why we have concentrated ourselves to this, making an equations. Okay, equations are there, matrices automatically comes up. Fine.
See, we can see it like this. We learned the concepts of matrix. This is a question, somewhat we can broadly see that it is related to probability. It's just that we are trying to model this question in the matrix format. This could be a point of view.
Yeah, you're just trying to solve the question, right? At the end of the day, you want to solve the question, and like matrices is helping you solve it. That's how I think about it. I don't know.
No,
Exactly.
modeling.
Because of the idea of converging, you were able to write ax is equal to x.
Yeah.
But before practically showing that they are actually converging, how can we write that?
No. There
I
is
am writing
even
it because I've seen it. Yeah, because
there is even a more basic question than this, and that question is, okay, we are going to make a model out of it. Fine, that is fine. But what is the pattern? If we were to generalize it,
I think we might know something if we continue so that ax is equal to x. We might get a certain hint.
When Nishan is asking about what is the pattern is the
iteration.
matrix. Yeah, the
First thing
pattern
is that
actually
there is
that
a
the columns
iteration.
are equal to the sum of the columns are equal to 1. Because we took an example where it is not the case, right? So what did we see in that matrix, right? If I took 0.3, 0.7, let me ask I'll invite everyone to follow me. I'm writing on the whiteboard. So I am just writing this out of my observations. And I think Maria and Chetan have also understood why we're doing this, right? So what is happening at the end of the time, I'm repeatedly applying this function on some input, right?
Fine. Exactly.
Right?
Mhm.
Exactly.
Mhm.
For this matrix, at some point, right, after many iterations,
Mhm.
The input and output becomes
this
similar.
is happening.
Right. Input and output become similar.
The input, whatever input you're giving, the output is actually the same. That is what is happening, right? When you converge at 416 and whatever 583,
Exactly.
right?
Fine.
You're
Fine.
inputting this and you're getting 416 and you're getting 583, right?
Fine.
Right? This is the observation we want to make. The observation is that if the matrix is of this form,
Mhm.
for now I'm making the statement. I will tell you. I will want to prove that it's not for all the cases, because if I take a matrix 1, 2, 3, 4, I cannot think of 1, 2, 3, 5. Sorry, I cannot think of any x and y other
Mhm.
than 0, 0, which
Mhm.
is being mapped to x and y.
That was my question. Now, what is the pattern?
Yeah, the pattern is this.
This is just a matrix. Fine. This is just a function to that
A
is to say.
matrix is a matrix is
Ah,
a
that-
function.
Try,
Right?
try
This is
to see the
just
columns, rows, and all the
at
things.
end
You'll
of the
get the
at end
pattern.
of the day, this is just a random number, isn't it? What is
No,
the
no.
pattern?
No,
The
these
pattern
numbers
is
are from our
from a
graph
probability
that we saw.
distribution.
Exactly.
From a
It's from a probability distribution. This is from a probability
Okay.
distribution. This is from a
The
probability
figure
distribution.
that we saw just now in the question, these numbers are taken from the
Literally
probability
representing it, right?
distribution.
Yeah.
Yeah.
that I understand. Fine. There is a question, and from that question we have taken this number, and this number combination of these numbers turns out to be a particular function where the x and y eventually converge. Sorry,
Yeah.
the input and output converges at a point of time.
Okay.
That is well understood. What I'm saying is that by seeing a matrix, or to say function in the form of matrix, how do we decide that this particular sort of converging function it is?
By looking at the columns, that's what I'm telling you, right? Because if the columns sum up to 1,
Okay,
this property is satisfied
exactly. Every time.
every time. That's what we saw it by
Ah,
changing the different values of the matrix. You maybe if you want to try it out, we have access to the Excel sheet. Try to change the values of the matrix, but make sure the columns add up to 1.
okay.
And whatever the matrix is, even if it is 0.001 and 0.99,
Mm-hmm.
right?
Mm-hmm.
It'll always converge.
This is beautiful, by the way.
Yeah, this is very beautiful.
And what has this got some name or what?
Not yet. We don't know of any name yet. Maybe we'll learn.
We are not audible.
Yeah, you're not audible.
Oh yeah, sorry. I think we can try simplifying. We were in some step, right? I think
Yeah.
when they came in.
Yeah. So Ashik and Nishan, you're up to date, right? What we're trying to do?
Hmm.
Perfect.
Yeah.
This is such a beautiful question and such a beautiful pattern to
Yeah.
observe.
Yeah.
So even if we do have a name for this.
Yeah. I'm not revealing it yet, at least.
Okay, I guess we are dealing with eigenvalues and eigenvectors.
Yeah. I mean, yeah, but that's a bit of a jump, right? How do
Exactly.
you-
That's why I was just
Yeah,
kind of
yeah.
pretending that there's nothing like that.
I don't get the intuition when that happens. Yeah.
Let us assume that we know nothing, let us go by basic principle. First
Yeah.
principle, I mean.
Exactly. That's what even Sir suggested. Maybe we should just try to simplify this. So what we want to do, the question is, we want to find an x and y for this matrix such that is this happens.
Fine.
You want to find that input which is getting mapped to itself, right?
Fine.
So any ideas? How would you proceed from here? How do you want to proceed? You guys can share your ideas and maybe I'll write it down.
I just found a way, interesting way. We can just break it down again in the equation. That is 0.3x plus 0.5y is equal to x, which will just, you can just write 0.3x plus 0.5y
Is equal to x.
is equal to x, which will
And-
simply give you y is equal to 0.7 by 0.5x.
Okay. Next equation would be 0.7y plus 5.5y is equal to y. 0.7x plus
Plus
0.5y
0.5y
is equal to
equal to
y.
y. And from the two equation, what I noted is y is equal to y by x is equal to 0.7 by 0.5.
There is a ratio you're talking about. Fine.
Yeah. Yeah, we can just simplify now.
Also know
Take
that
it-
x plus y
equations are
is equal
same,
to
right?
1000, right?
No, well, let me just say step by step. In the first equation, it becomes 0.5y is equal to 0.7x after subtracting 0.3. Point 0.5y is equal to 0.7x. Y is equal to 0.7 by 0.5x.
Let me move. How do I move? This okay.
First equation is 0.5y is equal to 0.7x. Is it?
Yeah, he's taking 0.3x to the other side.
Okay.
Y is
So
0.7 by 0.5 of x.
okay.
Now the similar for the next question, next equation.
Mm-hmm.
It's not much.
This is simply 0.7x is equal to 0.5y.
No, usually when you do this, you just substitute y is equal to 0.7 by 0.5x right here.
We can do what the subtract. If we do subtraction, the amount of calculation will decrease.
Okay, okay. So what do you want to do? Oh, you want to reduce it, right? That's okay. So you want to make it 0.7.
0.7x is equal to
0.5y.
0.5y.
Mm-hmm.
And here is also y is equal to 0.7 by 0.5x.
We also know x plus y equal to 1000. We can solve from that, right?
Yeah, but here I notice something peculiar. That is, this ratio is 1.4, and as long as we are maintaining this ratio, this matrix seems to have a solution.
1 second, 1 second. If I input y is equal to 0.7 by 0.5, I just get x is equal to 1, right?
Yeah.
Okay, and if x is equal to 1, y is equal to?
It's 0.7 by 0.5.
Sorry, Maria, I couldn't hear you.
2.5.
No, no, what I did is just
2.3. Are we looking at E? The constant E, isn't it? Just 2.3, I guess, no?
y is equal to 0.7 by 0.5 y x now.
Yeah.
He's taking x is equal to 1. Where is he here? 2.71. The value of E is 2.71.
What are we getting y equal to?
7 by 5, that is
1.4 maybe.
sorry, not E. It is 1.4. It is not E. It is not E. Show that ties. Fine.
Actually, we know that x plus y equal to 1000, right? So now two equations.
Muffled.
0.2x is equal to
Now it's clear.
Sorry? Chetan, did you say something? I didn't hear you. Sorry.
No,
X
no.
plus y is equal to 1000 is should not be in contention with these two equations.
No, that is okay. So if you so this is just
these two equations give you the same thing eventually, right? When you simplify, it's the same thing.
Exactly.
And I think that has something to do with that different idea that Sir talked. Because they are like,
Okay, these two equations are one and the same thing eventually, correct? Because the ratio of x and y is same in these two equations.
okay.
So I guess let us not discuss.
Yeah,
that
we'll
one.
just try solving it, I guess. So when you substitute, it's x plus 0.7x by
yeah, it is coming for 416. What is just substitute y is equal to 1.4x, and you will just get the calculation of value of 4.416.6.
Is it so? I should substitute it as 1.4 of
Y
x,
is
right?
equal to 1.4x.
Makes sense. So I want to put this as 1.4x is equal to
0.7x,
1000, right?
Yeah.
So
It is
x
just
is equal to 1000 by
x plus
2.4.
0.5 into
which is
1.4.
4.666, which was one of our answers.
Yeah.
And the value of y which I got is 583.33.
Yeah, that would be
it was
nothing.
it was
Y
same.
is equal to 1000 minus x.
583.33.
And here, if you will note now, one thing more, if we take their multiple also now, then also this uh, uh, input and output are same. If you are taking the multiple of 416, this values that we got x for x and y, then also the function is converging. Means
Yeah.
that is some sort of line, because we are seeing y is equal to 1.4x. So some sort of conversion means graphically something is happening somewhere in some space.
Can we try it the matrix way now, maybe?
Yeah, we should.
I don't know how it will go ahead, but let's try maybe. Let's see how it goes. I would have restricted you guys from doing this, but if this gives you some kind of intuition, maybe okay, that's fine. But yeah, in the end, you see that. How do you want to proceed from the matrix? Sorry, your voice is a little.
okay, I guess it's the internet. Okay, sir.
Yeah.
Yeah, you can write that as xy into the identity matrix, right? So, and then you can take that to the left-hand side.
And I think we should reduce A in the form of this, what we say, some sort of matrix. We might see something like diagonalizing something or upper or lower or in certain form.
So you mean we should do Gaussian elimination like thing, right?
But we cannot perform Gaussian here because the right hand side will also be
Be a
equally.
variable thing, yeah. Right.
Yeah, but can we factorize just A as a multiplication of two matrices such that we see some type of this column space or some type of arrangements there, here and there, a scaling or something? I'm just
Okay.
asking about A and not touching the x vectors. X vector.
So how do you want to go ahead? So yeah, if you want to try that, how would you try that? How would you do that?
for that, if I
Uh,
do that, will be eliminated.
can't we just write the right hand side as a product of
Let me go on with
on
that.
the left, just write an identity matrix into XY. So we can take that to the
Is this what you wanted to do?
yeah.
Okay.
Now, like if we have AB minus AC, we can take A common and write this. So if the AB equal to AC, we can just write this A into B minus C equal to 0, right?
So you want to take this to the other side.
Yeah, that will give us the same equations eventually, like which we solved in the bottom.
So you're taking this as AX and this as BX, right?
Yeah.
Okay. Now what do you want to do? AX is equal to BX. You want to do
A minus B into X equal to 0. 0 vector.
A minus B into X is equal to 0. Let's, what is a 0 vector? 0, okay. Do you want to write that as a matrix?
Yeah.
Okay. So that is nothing but 0.3 minus 1, 0.5 minus 0, 0.7 minus 1, sorry, 0, 0.5 minus 1. Awesome, okay. This into xy is going to 0, 0, you're saying. But what input goes to 0, 0 for a matrix?
0, 0.
And we know these two columns are
What input? What's the question? What input goes to 0, 0?
yeah. What value of x and y goes to 0, 0?
Okay, if it's 1, 1, then it's just only 0. Okay.
So maybe this writing of this equation is kind of wrong, right?
So
Is
is
it?
there any reason why we can't do that?
Wait. Maybe think, okay. Sorry. Let me think about this. 0.3 minus 1 is what? Let me write that actually.
Actually, you can only conclude x and y as 0. You'll get two dependent vectors. So you can't conclude that x and y as 0.
Yeah, I didn't see the dependence. Sorry. So this will be minus 0.7, right?
And in the fourth, I mean, in the 2, 2 position of the matrix, it will be minus 0.5.
Understood. You're right. This will be minus 0.5. Does this lie on the same line? Are these two dependent?
These are dependent.
Can anyone tell me that they're independent? Or why they're dependent, if they are dependent? Is this vector and this vector
Can I
lying on the
say
same
that
line?
how we go from this A to the current one? I was just
Sure. No problem. So what she wanted to do was AX, right?
Okay.
She represented, we know AX is equal to X, right?
Yeah.
Ax is equal to x. We know the identity matrix
Okay, yeah. You can multiply with that.
when multiplied with any vector gives back the same vector. So this adding this b before x doesn't change anything,
Yeah,
right?
yeah,
And now I can write ax is equal to bx.
yeah,
And if I take bx to the other side,
yeah.
which we can do,
Mm,
if we can do, it becomes ax minus bx, which is nothing but a minus b into x, right?
yeah,
Did you understand? You understand that part,
yeah, 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 yeah.
right? And that's what I've written over here.
Okay, you got it.
I mean, can we do that?
Ask,
I think we can. I think we
ask,
can.
ask. Yeah, ask about it. How? What? Can you do that?
I mean, that is a matrix operation, fine. If that is allowed, I don't know.
See,
we-
eventually you're getting the same equations that you got while simplifying it. Like if we write like it does ax equal to 0, that's the same equation we got when we did it numerically.
See, like we studied trigonometry and then we studied trigonometric equations. So
Question is simple, right? I think the question is the output of this. Let's say it's called A1, B1, because what is the first matrix? When I input x and y to this matrix, I get an output, which is a 2 cross 1 vector.
fine.
I'm
Up to
calling
that,
it A1, B1.
up to that point, it was very much clear that okay, we are multiplying with an identity matrix, but we
No,
are
No, I'm talking about the left-hand side. What is the left-hand side of this matrix? I don't know if you're following me, but I'm talking about AX is equal to BX, where that matrix is.
fine.
What is AX equal to? What is the output of AX?
So x is x. X
Yeah.
is the output of x.
Let's say we don't know if it's X. I mean, it is X, right? So this side is just, I'm just writing it as A1 comma B1. I'm just saying the output is something. It's a vector,
Fine.
right? We know it is equal to xy, but let me write it as a1 and b1. And this side where we have a matrix, again the same thing, right? We have a matrix multiplied with a input, right? Bx is nothing but a function being applied on the point xy.
Fine.
So we have one vector on the left hand side, one vector on the right hand side. Can we take the vector to the other side?
I think we can, because it's subtracting the same vector from both the sides, no?
It's like subtracting the same vector from both the sides.
Yeah.
But we
So
do we do that with real numbers. Can we do that with vectors?
With vectors are okay.
let's see it in a different way then. If we are adding two vectors, if
No,
we are
I guess see, it is not a straightforward. For example, I have taken a vector 3, 4. Fine.
Okay.
And we are adding a constant vector 4, 5. Fine.
This is equal to 7 plus 9, right? 7
No.
comma 9, right?
That is equal to 7 vector 7, 9. But is that equivalent to, and there is another vector. There is another vector. I mean, there are two vectors. If we add a particular same vector to both vectors, so the resultant would be same or different. That is the question.
let's try it. Just add 1 1 for simplicity, or 1 2 something, anything at both sides and see.
Both
Yes.
LHS and RHS are already equal. And
If they're already equal, yeah, if they're already equal. So if they have to be equal, I have to write this as 3 and 4. And if I add any X,
or of x and y, if we are going to add, then x and y is going to get added on both sides, and eventually the vector remains the same.
Mm-hmm.
I guess we can do it.
Yeah,
We can subtract it, I guess.
yeah,
It's fine.
yeah. Okay. So you understand that that is also possible.
That is well possible.
Yeah. It's not going against any of the properties of the matrices or anything, right? It's just you're subtracting a vector by on both sides. You're subtracting a single vector on both sides. That's kind of what you're trying to do. Yeah.
Now here the columns are same now. They are just multiplication. Our second column is just coefficient time the first column here.
Yeah. How? Can you give me?
That multiplication factor is minus 0.5 or 0.7.
Perfect. Perfect. So
They are along the same line then.
they are
Of
along
course,
the same.
they have the coefficients are same, so both of the vectors are going to coincide.
Yeah. So these two lie on the same line, right? So you're saying these two columns, these two vectors lie on the same line.
Yep.
Right? And if they do lie on the same line, then what can
There-
you say about x and y?
That will also lie on the same line.
No, not on the same line. I mean, what? No. For this equation, what inputs are mapped to 0, 0?
What input is mapped to 0, 0? They are, it will have a particular solution and spatial also, but without, there exists when x and y is not equal to 0 because it has duplicate column. One thing
One
Exactly.
second.
Yeah.
Yeah. Please repeat.
I
Yeah.
said because the columns are duplicate, are dependent, therefore there exists an x and y which is not 0, that is mapped to 0, 0.
Fine.
What is the nature of this existence? Is it a point? Is it a set of points? Is it?
So there are two inputs, or
Certain
more
them
than two inputs, so which is giving the same output, that is 0, 0.
Sorry.
I would consider it as scalar multiples only for this.
And that is going function wise. There are more than two inputs, more than one input, which is giving us 0, 0. Isn't it? This is what basically you said.
No, I said
Okay. Yeah.
that they will be multiple because that is inherent property of dependent columns.
And I'm talking about x and y. Inputs
Yeah.
are x and y, isn't it?
Yeah, x and y is input.
So multiple x and y, whenever we are going to input x and y, it is going to give 0, 0. That is to say, more than one input is mapped to 0, 0.
Yeah.
That's equivalent to saying there are other points other than 0, 0 which are being mapped to 0, 0.
0, 0 is
But
always
what-
mapped to 0, 0.
But what are those points which are being mapped to 0, 0? Is it a particular point? Is it a set of points?
Set of points.
What set of points?
It is of the form alpha, a constant time single point only. Because
So
they are-
it becomes eventually.
If we find a solution, then the rest of the solution will be a constant factor multiplication of them.
No.
No, for dependent.
Eventually it becomes all points become, we get, if we okay, no, not all points.
No. What I am saying, if you find only one value of x and y, and if you multiply it with a constant factor, And
Fine,
that will
fine.
be the solution. That is the property of this dependent and this null space, no? When we have null means when we have dependent vectors, then there exists this property.
I mean, let's try not to use the term null space, but let's try to understand the definition of null space without using the word. Let's go ahead. Yeah. Maria, do you want to say something?
Yeah, you can find, I don't know what the line is, but there'll be a line. I guess we found that 7x equal to 5y or something. That will have points. Like the points on that line will be the solution. Is what I think here.
Okay, she's saying there is an entire line of points
That is the solution.
that is
That is what we call infinitely many solutions.
so either there is exactly one solution or there are infinitely many, is it?
They are
Infinitely many. Both of the lines are coinciding.
What two lines are coinciding? Okay. Those two lines are okay. The first column and second column are coinciding. Okay.
So there are infinitely many solutions.
What solutions?
Every point that lie on those two lines on that line.
No,
Every
but
point that constitute that.
I think we should focus on finding that line first. Where is this XY line?
Okay. What Ankit is trying to say is give me an x comma y which gets mapped to 0, 0, which satisfies this equation. Let's do that first.
Yeah.
You know, you all know that there is an x and y other than 0, 0 that is getting mapped to 0, 0, right? That is what you've been discussing until now. You've been saying that the first column and the second column are dependent. They are on the same line. So there exists some xy.
It is
which
minus
is-
1, 1 and 1 minus 1, fine. If we take 7 and 5 out.
Yeah, if you
So it is, does minus make any sort of difference, Are they indeed dependent or not? I don't know.
okay.
What was the condition? Can you please remind me? What was the condition for dependency?
Yeah, let's do it slowly. So the first column and the second column. So the second column, the vector, right? 0.5 comma minus 0.5 should lie or coincide with the first column. For a 2 by 2 matrix, I'm not defining this for R infinity. I'm just saying this for R2, this is the case, right? So let's take the first vector, right? This is nothing but saying minus 1, 1 of 0.7, right? Right, let me just write this. So this is the first column, right? And the second column is
1 minus 1 of 0.5.
Yeah, let me move this side.
Not audible.
Minus 0.5 into what? Minus 1 comma.
Exactly. Now I said we can scale this by any factor. Let's scale this by alpha. Let's scale this vector by alpha and let's scale this vector by beta, right? Let me make these two lie on the, let me make what value of alpha and beta will equate these two. I mean, actually, you can do it in a simpler way. Like Maria said, you can do it in a much simpler way. Anyways, 0.7 is a scaling factor. Anyways, 0.5 is a scaling factor. So this can just be part of alpha. You can just think that anyways,
alpha.
Yeah, exactly.
That's
Right?
constant.
Anyways, it's a constant. So you can just actually ignore this 0.7. You can ignore it. I'm just going to ignore it, right? I'm going to ignore these two and say what value for alpha and beta will these two vectors coincide? Right? That's literally saying them lying on the same line.
One is 1 and minus 1. They're just
Alpha
See,
equal
one
to
minus 1 is different from 1 minus 1, isn't it?
yeah.
These two vectors are not coinciding.
no, they are coinciding. They are coinciding.
At one point only.
That is minus 1.
I mean, they coincide. Okay. How would you think about coincide? When you look at let's
I mean,
go back to
Just
GeoGebra.
factor is minus 1.
let us go to GeoGebra as well.
No, GeoGebra on hand, easy. This is just minus 1, 1 and 1 and minus 1, right? So minus 1, 1 lies here, minus 1 and 1, right? So sorry, minus 1 is here. So this is minus 1, this is 1, this is minus 1 and this is 1, right? So
Fine.
minus 1, 1 lies here and 1 minus 1 lies here. Are these two not on the same line?
They're on the same line. 1, 1 and 1 minus 1 would have been different.
Right? So this vector, when scaled by minus 1, will actually give you this vector.
Correct.
Right? Understood. Okay. Let's get back to the question.
Was there a pattern I was missing?
What pattern?
Was there a pattern? It was very much obvious to you or no, everybody, but not to me.
No, the only pattern that I see is once you get a dependent vector, they remain that.
No,
And
you find out dependence.
that I was confused about dependency. What was the condition for dependency per se matrices? We see matrices, and we see if the equations formed by these matrices are dependent or independent. What was the condition? Can you please remind me?
If a column is a multiple of another column, or if a column is a linear combination of another columns, then that vector is that matrix is a dependent.
Linear combination.
Yeah. In a systematic manner, if we say if a matrix is having just two columns, then first is independent definitely. But for the second column, if that is a multiple of the first column, only means you just divide
both
first,
of them are we get the first column itself.
Yeah, just divide the first element of each of both the columns and just see that if that is the multiplication factor. That is quite easy to see. But when there is a third column, there comes a trick. And sorry, that you have to see that the third column should also whether it is a linear combination of the earlier two columns or not.
Fine.
And for the three columns, that becomes a bit hurdle sometimes. That's why we usually use the approach of this Gaussian elimination and see that if at any step of elimination we get zeros in a complete row, that ensures that there is a dependency.
So if we are getting zero in any row, then how does that ensure dependency?
Because the line breaks now, you get one of the redundant equations. Like you are writing ax plus by is equal to c, a1x plus b1 x is equal to c2. Then you are writing a3x plus b3 y is equal to c3. But if you are able to eliminate one of the equation using the another two, then that means that is duplicacy. And there's one more property here, that is the rank of the rank of the column
No rank. Thank you, Ankit. Yeah. Okay.
And one more thing. The third column had to be linear combination of first two columns. How does that ensure?
Yeah. Let's go slowly, right? Okay. Let me do this. Chetan, do you understand? How you can check if a 2x2 matrix has dependent columns or independent columns? Do you understand how to do it?
Either the
columns are multiples of each other or linear combinations of each other, right?
Yeah.
Mhm.
So in general case, you say linear combination, but in a 2 cross 2, what do you check?
Multiples,
Multiple
right?
multiples.
Yeah. So what does that mean? You're just checking whether if I take the first vector and
Right.
scale it,
It's
right?
it's coinciding with the other
Is it
other one. Mhm.
for any value of that scaling factor? Let's call it alpha, right? That's what I've been writing until now,
Right, right.
right? If there is, so let me write that again. So here, right? For a 2 cross 2 matrix, here is a 2 cross 2 matrix. U with the first column as U and the second column as V, right? And if if you can express U as alpha times V,
Right.
right?
Mhm.
Mhm.
That means V lies on the same
Same access.
span of U. I'm going to use the word
Not
span.
access.
I'm going to use the word span, and
Mhm.
I want Maria to tell me what span is.
By axis, I meant line. Same line.
Yeah.
Mhm.
Line is one factor. You said line. That is very that's right. For a 2 cross 2 matrix, it will be a line.
Right.
Mhm.
But when I want to generalize this idea for a 3 cross 3 matrix, 4 cross 4 matrix, and things like that. So I want to introduce the term span, which I think we discussed yesterday. I just want Maria to reiterate what span is.
I don't think my understanding is that great either, but what I understand is sometimes to represent a line, we know that we need one vector, right? We just need one vector to represent the line, and you need one vector, and then it joins at 0, 0 to give you the line. So you need just one independent vector to represent a line. And
What if I take the
yeah,
vector 0, 0? Can I still make a line?
okay, you can't make a line with 0, 0.
I
Yeah.
can say it in a simpler term that each column vector should give something unique to you.
Yes, but it's not it doesn't sit on your mind easily. Let's go this step by step, right? So let us try to use the term of span. Let me maybe reiterate what span is. Maybe Ashik, do you want to just give a try on what span is?
I remember what you said yesterday.
If you remember, that's great.
Yeah.
You can also go ahead.
No, let Ashik finish first.
Yeah, if Ashik is there, yeah.
Yeah. So I understand the span is simply on a given space where all we can reach is the span. In simple terms, we can say that
Perfect.
for a
perfect,
line, we can reach for the for a line space, we can reach everywhere in that in a given vector. So that would be our span. Yeah, Nishnu, you can go ahead.
Yeah,
What's your
exactly.
take?
Exactly. If the line is as the x-axis, then the span spans from minus infinity to plus infinity.
Perfect.
Yeah, a good example. Yeah.
Yeah, that's the simplest way to put it. Yeah.
Perfect. Yeah, perfect. That's okay. So I just wanted to give, I mean, you said a vector and you can, so not any vector, but if I take a vector in 2D,
Mhm.
okay, any vector other than 0, 0, if I take a vector, what is the span of that vector?
We stretch it in the positive and negative direction infinitely, and we get the span of it.
Yeah. So
Line
what
passed
are,
through the object.
That is to say, vary the scalar part of it, and
exactly, what are you doing there? You are actually varying the scaling factor, right?
scaling factor.
You're varying the scaling factor. Now, question number 2. If I have two vectors,
Fine.
right?
Fine.
What is the span of these two vectors?
Complete plane.
If it is independent or
If these two vectors or addition of these two vectors.
Okay.
okay, two independent vectors might span a plane.
Exactly.
Sorry.
Right. So that there comes the dependence. What is the dependence telling us? The dependence is telling us, see, with the first vector, we have to look at it one by one. right? When we're looking at two vectors, when we want to understand what is the span of two vectors, first we'll take the first vector.
Hmm.
What is the span of this vector?
A line.
A line
Alpha.
passing through 0, 0 and that point, right?
Fine.
Yeah.
Line passing through that, right?
Fine.
Now, I will call the second vector dependent if it lies on the span of the first vector.
Fine.
Very simple, right?
Simple.
It is lying on the line which is already being reached by the first vector. That is what that scaling means, right? You're able to represent the second vector, which I've written here, u is
Mhm.
equal to alpha v, as
Mhm.
a scaled factor of the first.
Mhm.
Now let's shift to three vectors.
Fine.
How will you do this step by step?
To check whether one is dependent on another or not.
Yeah, how will you check the
The first
dependence?
the first vector is independent. Fine, we consider it independent, and the second vector, if it is not a multiple, a scalar multiple of the first vector, then it is of course independent. And now comes the turn of the third vector.
Mhm.
So we check it individually with a vector 1 and vector 2.
That's where we're going around. Okay, right?
Fine.
Now, the first vector. What is the span of the first vector?
Alpha times
Alpha.
Alpha times the first
v.
vector? Correct.
Alpha
Mhm.
times u, sorry.
Yeah, let's say alpha times u. The first vector is u, second vector is v, and third vector is w. The span of the first vector alone is alpha u.
Fine.
Now we look at v. If v happens to be on the line of u,
Uh-huh.
that is an easy check. You just check, is v equal to alpha u,
Fine.
Hmm.
right? That is an easy check. So now you know that, now you know how to check if two vectors are dependent or not, you're able to check, right?
And v is equal to alpha u, or
Yeah, it can go
v.
either way, right? I mean, 1 by alpha is still any scaling, right? U is equal to alpha v, right? It's okay. One vector, if you scale it up, it'll become, say, 2 times u is becoming v. You can say u is equal to half of v, right? That's the same thing,
Okay.
right? It's the same thing. So it's okay. Alpha can come anywhere to understand. So now what you're missing is, what is the span of these two vectors?
Added together.
Span is any point that these two vectors together can reach. You already made the check
Together
that
can reach.
exactly the linear combination of u plus v. That is what we do, right? What is the span of two vectors in R2?
If two of them, if we have checked that two of them are independent, then definitely the third would lie. Third could lie on any plane. Fine, that's fine.
We're looking at R3 now. Don't forget that we're looking at R3. We are in R3 space, right?
R3 space. Fine,
Yeah.
fine. If that lies on linear combination of, if that lies on the plane of the combination of those two vectors, then exactly then they are.
So the first vector alone, you had to check the span of the first vector was a line. You just had to check if the second vector lied on that line.
Line or
Fine.
not.
But when you're looking for the third vector, now the first two vectors don't just create a line. They're not independent, like they are independent, right? So you cannot think of, oh, does it lie on the line of u? Does it lie on the line of v? If it doesn't lie on the line of u or v, can I call it independent? No.
No.
Because u and v together, the span of u and v itself is a plane,
Fine, fine.
right? So you just have to check for the
Because
W.
because at end of the day, the equation is going to make a linear combination. That's why.
Yeah. Bye, Praneeth. Thanks a lot for joining the discussion. Yeah. Yeah. So we just have to check whether the next. So how do you generalize this?
So if we are having, yes, Maria, go on.
Actually, I don't think I was about to say something. Sorry. I think, yeah, I don't know.
Actually, I think we should solve it, because after solving it, I got the values of x and y, but after I am plugging that x and y in the initial equation, they are not solving it. They are not returning x and y.
Which equation?
Yeah, this one, na? This minus 0.7 by 0.7, 0.5 by minus 0.5. You can just write the value of x and y that I found that solves this equation.
What
That
is the x and y that you found?
0.5 divided by 0.7 and another one. I just scaled them, rescaled them.
I didn't understand that. Sorry.
Just write x and y is equal to
Yeah.
0.5 by 0.7.
X and y. So I'm writing it here. I don't know if you are able to see.
Yeah, I am able to see.
X
Equals
and
to
y equals to
0.5 divided by 0.7, x value,
0.5 by
divided by
0.7,
0.7, and y key value is 1.
1.
Yeah. Now you
Okay.
can see
I
this.
think you might have made a
X value
calculation
will solve-
mistake. Ankit,
X
can you
value-
tell us like how you actually came to that?
It's just a multiplication factor. Multiplication, na. One column is multiple of another. What is the multiplication factor? I just checked that.
Okay,
It's-
that's actually the line, right?
Yeah.
Like our specific solution we'll only get when we add one more equation, which we didn't actually use the metrics to represent. That is, you have to also try. This is the okay, I can't use that term, but this is the I'm not sure it's correct.
No, we can just plug in the value of x and y and multiply with this minus 0.7, 0.5 wala geometrics. Yeah? This dependent matrix with that dependent is written, and see if you are getting 0 or not.
Yeah, we are.
We are, and if we are plugging this value in this original AX matrix, you are not getting x.
No, 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 no. That is not this. That is not what this is.
Okay.
You actually found a point. What did you actually? What question did you solve? Always remember, try to make sure you have the question clear in your mind and what you're trying to answer. So what question you were trying to solve is what point other than 0, 0 when multiplied with this matrix is going to 0, 0. You found one such point.
Yeah.
I want to know what are the properties. Is this the only point?
No, it's multiple are also point, and any constant times this will should also satisfy it.
So you're saying if xy is equal to alpha times 0.5 by 0.7, 1, right? If
Yeah.
xy is equal to 0.5 by 0.71, then the output is equal to 0.
Yeah, it should.
Right?
Yeah.
What does this mean? What does alpha times a vector mean?
It just scale up or scale down.
What is that? What is the span of that?
That is just this R align.
Right? And
Yeah.
this is nothing but the null space. Null space is all the points which are being mapped to 0, 0 is nothing but the null space. For this 2 cross 2 matrix, the null space happens to be a
Okay.
line.
Earlier, I thought that that null space was only the point that origin only, but here we have some different points.
Like
That are-
null space is the origin only when the vectors are independent. We saw that the previous day, right?
Yeah, but in the dependent case, we have certain different
We will have other points like that whole line will be a null space. Otherwise, it's just the single origin.
Okay.
Exactly.
Means for the dependent case, we are expecting the null space to be at least a line.
Yes.
Yeah.
In this, okay, I'm not gonna say at least. Okay. Yeah, if you have a dependent, okay, yeah, what you made, the statement you made is true, but it's not very easy on the mind, right? It's a very uh, cooked up statement. Let's think about it like this. If I have dependent variables, if I have a matrix which has dependent columns,
Hmm.
the null space is more than a single point. Why?
Okay.
Because there exists some other xy for which the output is 0, 0. Let's
How do we
take it
say
step by
that?
step. Yeah.
Yeah,
Nishan?
at
How do
least
we
I
say
said,
that? How do we
at
say
least
that?
I said because line here it is a line. But if we had like two vectors, even if we initially would have three columns, and one of them would have been dependent. At that time, we would be seeing a plane. That was a null. That would have been a null
You
space.
understood. I'm very happy that you understood this. I'm very happy that you understood. How it even goes up to third dimension or fourth dimension. Very good. That is a very good understanding of null spaces. But yeah, very good that you can do that. Now I want others to also slowly realize this. I want them to also slowly take this step by step and understand what is happening here. Nishan, did you understand why the null space is a line? Is he there?
What if two planes cut? We get a line. Fine.
Sorry, what if?
Two planes intersect. We get a line.
Okay. What does that have to do here?
I'm trying to make a geometrical interpretation of that.
Very good. Keep thinking about it. So let me try to guide this. Okay. When we said any point other than 0, 0, right? If I have any point other than 0, 0, like a vector 1, 2, right? If 1, 2 is taking, okay, let me write. Actually, this is a very important thing. I don't think we discussed this before. Let me write this down. Let's take a simple matrix 1, 2, 3, 4. Oh my God, this is such an important. Yeah, I mean, it's very simple. I mean, after I explain this, you'll be like, oh, this is very simple. But seeing it like this is very, very important. I hope everyone's seeing the new matrix I've written. I've written 1, 2, 3, 4, right? And I take input 1, 2. Where does this go to?
It will go in a plane.
5, comma, 11.
So this is
5, comma, right?
1
Three,
plus
seven.
4,
5,
which is
comma, 11.
5, comma
11.
3 plus 8, right?
5, comma, 11.
Yeah. Question. Where, okay, let me do this step by step. Okay. Where does it take the input? 2, 4.
10, 23.
Where does it take the input? I don't even want you to see the matrix anymore. You should be able to answer this with just what information is there here.
50 by
110.
50 and 220.
Mm-hmm.
50 and 110.
50 and 110, yes.
What are you observing?
The output is also getting multiplied by the same scalar.
Exactly. So if I take a point, so 2, 4 is nothing but 2 times 1, 2.
Mm-hmm.
10, 20 is 10 times 1, 2.
So yeah, this is nothing but 10 times 1, 2.
Same on the other side.
So, and if I take 2 outside over here,
And
what will this become?
5,
1, 2.
5 and 11.
Exactly. This is a very wonderful property of matrices, or very wonderful property of linear combination. Actually, this is a property of linear combination that makes it a linear combination. The definition of linear combination requires that function when applied to x comma y,
Mm-hmm.
if it is equal to a comma b,
Mm-hmm.
right? Or actually, let me write it as a linear combination. That will be better. If I write it as a linear combination of, what is the matrix? 1x plus 2y. So x plus 2y, comma 3x plus 4y, right? 3x plus 4y. Right? Function of alpha x comma alpha y.
y.
I don't know if I should, I'm not sure if this alpha should be outside or inside. Okay. Yeah, it should be inside, right? Yeah. Input is alpha times, maybe what I should do is,
Alpha times xy, we can also write that, I guess.
yeah, that will be better. So this will be alpha times xy, right? If I write alpha x alpha y, that will actually be alpha x plus 2 alpha y, comma 3 alpha x plus, sorry, 4y, right? 4
Yeah,
alpha y,
4 alpha y.
right? If I take alpha outside, it is nothing but x plus 2y,
3x plus 4y.
comma, sorry, 3x plus 4y. You're right. So this is actually a defining. This is what makes linear combination so nice.
Hmm.
I don't want to use the term, but isn't this a property of linear transformation?
Yes, this is a property of linear combinations. You're right.
Now we get it, from where this property comes. It comes from the nature of the linear equations.
Exactly.
Hmm.
So what does this mean for us?
Really.
It means if I take a point and do the matrix multiplication, which is 1, 2, 3, 4. This is the input and this is the output, right? Wherever this point, say this is going to this vector,
Mhm.
then say this is 1, 2. 1, 2 is going to x plus 2y. So where does it go to? 5, 7, right?
511.
5, 11, right? 5, 11. Then any point on this line will actually lie on this line. Any input I take from this line.
Will
If I take,
lead me to that line.
exactly.
Not just 1, 2, any point on 2, 4 as well.
Exactly. I mean, 1, 2 and 2, 4 are lie on the same line, right? Because you think about 0, 0 connecting with that point.
Scaling, that's it.
Sorry.
That's
Yeah,
why it's called linear transformation, because it's transforming one line to another. Okay, that's
Exactly.
so yeah. This was really nice, yeah.
No, 1, 2, I get it. It could be 1, 3 as well. Fine. Any point on 1, 3 would also lead to 5, 11.
Exactly. If I take another vector which is not on this, if I take like you said 1, 3,
Mm.
that will actually go to one
This-
particular line.
No, 511 only, no?
No, no, no,
No,
no,
no.
no, no, no.
No, 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 no.
See, only the inputs that are on the line vector 1 comma 2, those will be mapped to the line of vector 5 comma 11, because you are scaling it by some scalar quantity. If you have some other vector, say what was the 1 comma 3, right? That's what you said. If you
No,
if
no.
you,
The thing in my mind is that
Mhm.
511 is the
Mhm.
so what are you suggesting? 1, 3 and 1, 1, 2. Fine. We have two vectors. We are taking sum of both. And we are
Don't
getting
think
511.
about sums. No, no, don't. No. Don't think about that. So that's why I want to think about only one vector. So think about one vector and try to solve this. I am saying that what is this part of the equation saying? It is saying if I take an input xy, which is
Mhm.
for our example 1, 2,
Okay.
it gives us some particular point on the output, right?
Fine.
If I take alpha times that input, which
Okay.
is nothing but saying any point which spans this,
Mm-hmm.
right? Which is 2, 4 includes that.
Got it.
Exactly. Then the output also lies on the same line at a scaled factor.
Fine. Exactly. The
Yeah.
linear combination.
Exactly.
Linear transformation.
Yeah.
Actually, I think we went through a lot of stuff which wasn't related to the question, right?
Mhm.
Like,
No.
wasn't that
This is a very important point of our question. I mean, for us to understand null space, I really wanted us to go through this entire step. Now, very simple. Ankit gave us a particular point. He gave us a point. I'm not able to write that point since I think it's 0.5 by 0.7, right?
Yeah, it's there. Yeah.
You can write 0.714.
Huh?
Fine. 0.7.
Yeah,
0.7.
let's say this vector, right?
Now-
I'm sorry, it's on the negative side, but imagine this is a vector.
Mhm.
This is being mapped to
Output
what is our
0,
it is being mapped to 0, 0.
0.
So if this point is being mapped to 0, 0,
Any
any
point
point
on that line
exactly,
Right.
will be mapped to 0.
exactly.
Mhm.
Right? So our null space,
Would be a line.
exactly.
That's why it's a line.
In this case.
Yeah, in this case, it's a line. There are cases where it can be more than a line.
Or a point maybe.
Null space, if it is a point, what would be that point?
0.
0.
But
Exactly.
one thing I can note is whenever we are using the term space,
Mhm.
ultimately we are seeing from the point of view, what does it lead to ultimately? And the highest thing that it lead to, we call it by that name. Like if a linear combination lead to a line, ultimately, nothing more than that, then that is a line space. Its here is leading just to us to the origin. That's why it's called null space.
Mm.
If there was some sort of combination is only leading us to a plane, then that is a R2 space.
Yes.
Okay.
Okay, so this is understood, right? I'm sorry I deviated from the question. I think Maria was in a flow. Maybe I shouldn't have gone this much, but I really wanted them to understand the null space from what was here.
I kind of liked that part where you drew the like when the linear combination becomes one line becomes another line. That's really
Yeah.
a good way to think about it. Yeah.
Exactly.
We apply a function to a line and it becomes another line.
Yeah, it becomes another line. That's the simple way of understanding it here.
Exactly.
Maybe time travel we can do.
Is this property shared across all the matrices? This transformation is symmetric. Like means yeah, for the independent that is definitely so. For the when we have independent column vectors, but for dependent matrix vectors, I think the rank that is the space should decrease by a rank, no?
Yeah, I don't know what rank is. So it's okay. Let's
No,
not talk about rank yet.
yeah, in a simpler term, if we had a dependent this
Mhm.
vectors, no, let me think more and then
Yeah,
say.
yeah, sure, no problem.
Yeah, let's return to the question now.
Okay, sure. So now we have understood what null space is. I think I'm very happy all of you have understood what null space is. I think that's one of the most beautiful things because once you understand null space, you start understanding column spaces, row spaces, ranks, everything. You understand everything. Like that's why I think Ankit is also very, he I think he is also relating it to the concepts he knows. But let's not think about what we know. Let's try to build up the concepts one by one, like how we are doing it now, right? Null space, the way we reached it, I think the way I learned it from sir is exactly how I wanted to put it through to you people as well. And I think that way of learning it is really very, very interesting. Okay, so let's continue the question maybe. So now what do we do?
Now we have a value of x and y, then where we can go to find the ultimate x and y.
Yeah, we found the null space corresponding to
This
the
matrix. Yeah.
yeah corresponding to this matrix. Now what we do is we also know that the solution is lies on x plus y equal to 1000, so we can solve it. Is there
So how
anything
do you want to
else?
go? How do you want to go from there? Yeah. So wait, let me erase these, but this is not very interesting, right? I can take this out, right? This is fine.
No, why erase it? We can start writing below it.
One
Yeah, I
thing
just wanted a flow of this
I
question. That's
cannot,
why.
like I was exporting this as PDF. I
Uh-huh.
was able to export the complete board in a
Mhm.
single PDF.
Yeah.
Only a small section was coming. I
Are
don't
you
know
sure?
why.
Let me see. I exported it as well. Let me see if it.
Just export it and open it and just confirm.
What
No,
happened?
no. So it's coming
The
out to be
contact
correct.
Select all, do select all, no? You would
Yeah,
have
select
selected
all.
page one only.
Yeah, Maria, go ahead, go ahead. You can still put your thoughts. You can share your thoughts. How do you want to
So
go ahead?
we didn't actually. There was a part of the question where we didn't find out why it converges, right?
Yeah, so that's why you wanted to do this, right? You took ax is equal to bx, and you wanted to try to do it with something to this, right? You took bx to the other side. You got a minus bx is equal to 0. So here we
Yeah.
are right now. Can we do something from here? Maybe.
From which perspective did we get the conclusion that they are converging here?
That convergence was from the Excel sheet that we saw, and
Okay, cool.
also,
Now,
yeah.
here is one more interesting fact.
Mhm.
Like if you see the original A, then there the columns are independent.
Yeah.
But when we this transfer the side using this identity matrix, the columns itself become dependent.
Hmm.
So does this transformation say something about this convergence? I don't know, but
You want to take an example of another matrix and check if this is happening only for that matrix or this or all matrices?
Yeah, for the case of convergence.
Very
Uh,
nice. Okay. Very nice.
That's actually quite nice, yeah. Like, we should check if there's some property of the matrix that tells us if it's converging, right? That's what you're suggesting.
I think we should note it, but first we should reach the solution, because yesterday also
No,
we are not reaching the end point. We can
Srivinash suggested the pattern is that the sum of the columns is leading us to unity.
Mhm.
Wasn't this the pattern?
That was the pattern. Yes, that is the pattern.
no, but
But how
that
do we find the x and y? Which input? So, okay, I'm giving you a matrix which is showing you.
Oh, okay. So
no. I'll let me
we
contradict.
solve and find out x and y.
If this was an identity matrix, and if we have subtracting it, it would have resulted in zero matrix only. That in that case, you cannot ensure that it is converging or whatever that thing is happening.
Mhm.
So I think we need to reflect on this thing, that does this transformation of independent columns to the dependent columns during this addition or subtraction or reduction, means transformation of the matrices,
Mhm.
has something to do with this convergence.
Okay. Can someone just quickly tell me if A was something other than this, say 1, 2, 3, 4, right?
Will it
And I
converge?
and I and
Or
I
we
re- no, it won't converge, right? We already saw that, right? Oh, yeah. Okay. Okay. If I take a matrix 1, 2, 3, 4, will it converge? Can someone give me a quick
it's not
counter?
a
You can take an example of 2112.
2, 1, 1, 4.
2112.
2, 1, 1, 2. Okay.
Row wise.
Yeah, row wise.
2, 1.
I'm writing it somewhere else. So you're telling me if I take 2, 1, 1.
1 2.
2.
Okay.
Now the columns are column vectors are independent.
Mm-hmm.
First thing we got times x should get x, and that
Mhm.
we can write as identity time x at the right side.
Yeah.
Now, if we still do the subtraction,
Mm-hmm.
where do we get? Like it becomes 1 1 1 1. Okay, yeah. They becomes dependent again.
Mm-hmm.
And are they also converging? We should check. I think we should go return to the Excel and see.
Sure.
see,
One thing,
it's converging when the values actually reduce, right? One value has to reduce and
Exactly.
another value has to increase.
Exactly. Now, Ankit is trying to say, what if this is the property? No, he's right. I mean, he's just trying to say, speculate whether, oh, if there is a matrix which when subtracted with the unit matrix, which is the identity matrix. No, I didn't mean to say unit matrix, sorry. With the identity matrix becomes dependent, is that the reason why the convergence is happening? But Ankit, just give a thought for a second. What is this equal to? Before I even go to the Excel sheet and try it out, before we go there, what is this equal to? This is x plus y,
Acha, okay, that.
comma x plus y, correct?
Yeah.
Now, as I increase x and y, what will happen to x? What will happen to the output?
It will also increase.
It will keep increasing.
But we need one of the outputs to decrease and another to.
No, if we had the value of x and y as +1 and -1, then
Mhm.
that will lead us to the null space.
Okay. No. Okay. What I'm trying to say is, if you want convergence, you need this to be equal to this. Is that right?
Yeah. Yeah.
X is equal to X plus Y and Y is equal to X plus Y.
No. I think you just took it to something different.
No. Okay.
Just compare both the steps that we did in the earlier and this one.
Sorry, which one?
The earlier example, this 0.3, 0.5, AX is equal to B. After we subtracted, we make the right hand side equal to the 0, 0.
Mm-hmm. So you're
So
trying to find the null space of this. That's what
yeah,
making it 0, 0 means.
yeah.
But what we don't want to think about null space. What I want is, does this function, when inputted xy, give me back xy for any xy?
Yeah,
That is the main question.
there exists a set of xy that is alpha times minus 1, 1 or alpha times 1 minus 1. There exists a complete line for that.
It goes to 0, you're saying, right?
Yeah. You can just write and see that.
Yeah. Wait. So there is a null space. Okay. But convergence is okay. When we talk about convergence, the third condition that was there in the convergence is this. So
And
that means both numbers have to be,
till the
I mean,
1000 inflation, it is not converging anywhere. I just checked.
yeah.
Null space or line space?
I think we should drop this idea.
Actually, x should be greater than 0 and y should be greater than 0 is also two equations because humans cannot be negative. Maria?
Sorry, number of people can't be negative. Yeah, that's correct. But when we do convergence, we're actually getting a fractional value, right? It's not an exact real
Exactly.
number.
You're right.
So
I mean,
mm,
yeah,
there's a
fractionally.
slight oscillation, I guess. Like it won't remain completely fixed, but in almost convergence. Right?
So
Yeah.
this thing has something to do itself with the sum of this column vectors.
Columns. Yeah.
Okay. Column vector as sum. But I don't get the exact idea, but saying that it has something to do.
See, when you talked about null space,
Yeah.
you were trying to find x and y which map to 0, 0.
Yeah.
But that does not satisfy the fact that xy is equal to the output. If xy were equal to the output was 0, 0. So x and y have to be 0, 0. That is already true. 0, 0 always gets mapped to 0, 0.
Yeah.
So is there any other, I mean, see, that's the thing. A few things, I mean, this condition obviously added will obviously, take this away. Like tell that this is not the right condition that has to be satisfied. But one more thing to see is, I mean, we wanted xy such that output is also x and y. But when you take any xy in the null space, which is a line, the output is 0, 0. And the only thing that can satisfy this on the left hand side is 0, 0. Only 0, 0, 0, sorry, only 0, 0 is being mapped to 0, 0. There is no other xy which is being mapped to xy.
I think I will think about this more.
Sure.
Yeah.
Chetan, are you confused about this?
Yeah, trying to figure out.
Okay.
I am actually I would put a thought in this because we were earlier defining this thing itself that ax is equal to x. After subtracting it, it should right hand side will be 0. because we are subtracting. We are taking
Mhm.
what was the right hand side away from both the sides.
Mhm.
So we already took something from the right hand side, then that is just vector.
Mm.
And if we are just returning the one step before itself, then that is a bit contradictory for me.
Yeah, understood. Hmm. You're right. Yeah,
Can
I
you
think.
repeat the last line?
Yeah, sure.
One,
Ankit?
what is one step before?
No, no, what? Okay. You see this thing that where's this marker? This thing here. Uh, how do we erase it? Yeah.
No, it's a highlighter. Yeah, go ahead.
You see this thing here? I have just bracketed left side, a bit left side.
Yeah. So the first main equation that we're looking at, ax is equal to bx, right?
Yeah.
So okay, maybe Nishnu,
I,
let me
I, I think,
try to
I
say what
think
he's trying to say. See, he's trying to say the left hand side of the equation, which is ax is equal to bx,
Mm-hmm.
is saying
We are
that
subtracting it. I'm getting it right.
no, forget about subtraction. What is that equation saying? I am giving an input to A and I'm getting out the output as this input, right? That is what it's
Mm,
saying. I'm
fine.
inputting x to function A
Mm-hmm.
and I'm getting output as x.
Mm-hmm.
When I manipulated this equation
Mm-hmm.
to get what is on the right hand side
Mm-hmm.
and I
N
solved
minus
for
one.
it and he solved for it,
Mm-hmm.
which is xy is equal to 0.5 by 0.7 and y is equal to 1, right?
Mm-hmm.
Anything on that line, right? Anything on that line.
Mm-hmm.
Why suddenly that property is not there anymore?
Okay, this is a good question, but I guess I know the answer.
Mm-hmm. What is the answer?
there's one more property related to the matrix that says A B is equal to if is A B is equal to C B, then A and C should be equal to.
No. Then my simple, not I'm not talking about any law or any rule, but
No,
in
no,
general.
it's just simple multiplicative property now. It's
No, no,
simple
no.
numbers.
A simple logic I want to reiterate is that forget matrices.
Okay.
We are proceeding to solve a linear equation or any equation per se. So what we do is that we are given a problem, we carry out particular steps, and we come to the conclusion. That is, we find the solution. So why ponder about the intermediate steps?
No, but here we got a solution. We got an x and y value. But when we are putting that value in this function, that phi, ax is equal to b, then we are not getting the x itself. So why is that?
So you are saying that when we are following all those intermediate steps and then finding out x and y, then x and y is not satisfying the x and y is not giving us x and y back,
Yeah.
isn't it? But I
Yeah.
guess it will not give x and y because it is going to converge and not exactly converge. It will it will convert it will be equal in a limiting space. So it will be nearly equal, not equal, 100% equal, isn't it? I mean, it's exactly, it's not getting, if after every iteration, it is not returning the exact same result, but nearly same result, that we can ignore as an error. In third or fourth.
Let's try and solve it now. Because this is giving us far off values, far off. It is
Can you
giving
tell me like how you actually reached to from this equation like from the last we got two dependent vectors in a matrix, right? and into xy equal to 0, 0. Like from that, like how did you reach?
Okay,
Uh,
look. The simplest condition to check the column dependency is you just divide the first element of both the columns. That becomes your multiplication factor. And you can consider it as a multiplication factor. And now multiply the second element of the first vector and see that if you are reaching the second element of the second vector. If you are reaching
like,
them, that they are dependent vectors. If they're dependent vector, then same multiplication factor will have a relation with their linear combination that will lead to 0. It is like saying that +1 -1 equal to 0. You can just draw it. You will see it in a much better way if you will draw it.
let me just take my writing pad then 1 second.
Okay.
I want to say one thing is that why we are trying to relate. Okay, I guess there is some relation. Why are we trying to relate these first step and second step? Because what is happening is that in first step the equations are independent, and then in the second step the equations become dependent.
We are not trying to relate it, but our target was finding an x and y, which returns us x and y.
I understand, and it's not returning that. So my first concern is that equations, when we are trying to, for example, trying to take any approach to solve equation via Gaussian elimination or anything, the nature of equations must not change, isn't it? I mean, if the equations initially are independent, it should remain independent throughout. Or in intermediate steps, it could become
No,
dependent.
this thing should not happen, from my understanding.
I mean, dependency should be same.
Process.
Yeah, actually, like Ankit, can you tell me how you reached that xy is equal to 0.7 by 0.5 comma 1? Yeah, that's what I didn't understand actually.
Okay,
So I write it down, like
that
I
is
got my
quite,
writing.
yeah. If
Like I don't think you'll get that solution exactly. I'm actually writing here, like below that, on the right side of dependent.
yeah,
You'll have to invite everyone to follow you.
Okay, okay. How do I do that?
I button top right corner.
Yeah, okay.
so follow it.
Yeah, so see, the only thing you get is that this is
Your
very
voice is
clear.
breaking. Your voice is breaking.
Okay, maybe this. You have to go to a different position. Okay, is it better now?
Yeah.
Fine.
Much better.
Yeah, okay. So, is okay. Okay, like just think about it in this way. Like why what we got earlier and this metrics are actually exactly the same thing. Like when we solved, we actually got y equal to 0.7 by 0.5, right? This thing that I'm rounding here, we got that, right?
Yeah.
So now just like this thing, forget about the solution, everything. Just write this as an equation. What will be the equation corresponding to the matrix minus 0.7, 0.7, minus 0.5 xy equal to 0, 0. You can write it as minus 0.7x plus 0.5y equal to 0, right?
Yeah.
Isn't that the same thing we got here?
Wait a sec.
Yeah.
By using, like, by just solving, by
Right.
substituting and solving.
Yeah,
So,
first equation we got the same, but what about the second? Is it also same?
Yeah.
second one is also same. Second one, you'll get the negative of this equation.
Yeah,
0.7x minus 0.5y equal to 0.
no, but the idea was using this approaches. We solved this question using these equations and their solution, elimination, so on. But uh, what we wanted to find is this equation solving is not scalable that much. That's why we wanted to solve it using the matrix approach. But now we are stuck somewhere.
No. What I'm saying is that the only thing you did is that, like, the only thing actually you did to convert it to the same equation is by multiplying it with that identity matrix, so that you can manipulate it as matrices, right? So actually, the same step that we applied here, that's 0.3x plus 0.5y equal to x, and 0.7x plus 0.5y equal to y. We're doing the same thing in matrix form in the at the top. That's why in the end we're ending up with the same equations. So like can you tell me, that's why I asked, like, can you tell me how you got this, right?
This
xy
expression,
equal to
yeah,
0.7 by 0.5. Oh,
0.5 or 0.7.
okay, 0.5 by 0.7,
Yeah.
comma 1. Like, how did you reach here from this
That
matrix?
is simple. What I did is I just took the A11. I just divided it by 0.7 and multiplied it with 0.5 and just tried adding. That was means I was just looking at the combination of columns. What set of combination?
One second. When I'm solving it with the help of calculator, it's showing math error.
Yeah, because this system does not have a solution. This, like, the only equation that we get from this system is 0.7x minus 0.5y equal to 0. So we have two variables, one equation. Can we solve? We can't solve, right?
Fine.
When we actually use this equation and the equation that x plus y equal to 1000, then only we get x equal to, I don't remember the value, I think it was 417 and 583.
Yeah,
Just plug,
that,
let me plug that in.
yeah, at that time we did.
Yeah, right.
What's happening? Sorry, I think I'm lost.
Okay.
No, like I didn't actually understand the step when this stuff came, like 0.5 by 0.71, that solution came. I didn't actually understand, so I asked him.
It was same, just
Yes,
I think
what-
my
what
sanity
we
is
did in
too
earlier
Zero.
equation was this thing, that along the equation of
One
this,
plus
this
one
0.7x minus 0.5y is equal to 0
minus
would not have given us anywhere. So we used the extra additional equation that we were having, that is x plus y is equal to 1000. And evaluating these two equation led us to the answer. So I think we need to include that thing in the matrix itself, that x plus y is equal to 1000 somewhere.
Okay. When Maria, okay.
You mean third equation, huh?
Yeah, we need to include it somehow in the matrix if we are going to solve it using a matrix. Because in equation we required it to get to the answer.
Right. So the answer is 583.33 and
417.
417.66, yeah.
One second. When Maria said she didn't understand, what is that? What did you not understand? Can I just?
Yeah, this part where it became 0.5 by 0.7, where from this matrix you got to the solution xy equal to 0.5 by 0.71.
Mhm.
I didn't understand that, but let me just rub that. I think it's not
one.
clear.
That
So you want to find a point that goes to
Yeah,
0, 0.
like I didn't understand how. Yeah, actually this is just the
uh,
yeah, last time also I got stuck here. This is actually like actually y equal to 0.5 by 0.7x is the line,
Mhm.
is the null space, right?
Yeah.
For this for this
Yeah. You're asking how he found that
function.
out, is it?
Yeah, how we actually got to this? Like, I think Nishan actually tried it in a calculator and you'll get math not found. That is the correct solution, because we only have one equation and we're trying to solve
no,
two variables.
You know how I will solve this?
Yeah, you can try.
Can I try solving this?
Stop pressing.
So when you know, it's okay. How did we find that the two vectors
I
were
did not.
different?
I did not
Yeah.
get Maria's question for at first.
No, she is just saying if you have, see, what is it? Okay, what happens when two vectors are dependent and that is forming the matrix? The first equation and second equation, actually, the second equation is redundant. That's what it means, right?
Mhm.
So how are you able to solve one equation with two variables?
No,
How
she
are you
was
able
trying to
get-
represent it via XY and 0.7
What-
something.
what-
What was that?
No. Yeah, this
What-
was something actually Ankit said
about
that he
that?
found a solution to.
We
From this
know-
matrix, like this is the question mark. Like,
No, you can, what we know is we can write this AX is equal to 0 in the form of, we can say it in the form of linear combination. And for that linear combination, we just need the right amount of X and right amount of Y that leads it to 0. But because here the columns are dependent, therefore they have a similarity, that is, they have a common multiplication factor. That's why I just
Okay.
multiplied
Ankit, very good, very good. I loved how you started out with linear combination, and I understood that you understood how to solve it from there. Maria, do you understand what happens when we take the column view of this matrix? Can you write the column view of the matrix?
yeah, where is their space? Yeah.
Maybe
Okay, I'll
below
go
it
there.
or above it, anything?
Above it, or on right side of it.
Okay, can someone repeat what the matrix was? 0.7, 0.7 minus 0.7
And
minus
0.5.
0.5. Here was
0.5
0.5. Okay.
Are you writing below or
Just follow her if you can. Click on the list of people.
Is
And
this
you
the
can-
matrix? I don't remember.
Maria, can you request everyone to follow you?
This is the
I'm
matrix.
fine, I'm following. I got
Yeah,
it.
Okay.
This was the matrix. No.
No.
Yeah, this was the
Is it?
matrix, right?
No. Replace columns with
No, yeah, this is not the matrix. This is
rows.
not
So minus
dependent.
0.7, minus 0.7, 0.5, and 0.7 minus 0.5.
Okay, minus 0.7, 0.5.
No.
Yeah,
0.77 and 0.55.
Okay.
Minus 0.7, 0.5, 0.7 minus 0.5.
See, A11 is positive. A12 is also negative, and A22 is again positive.
Minus
Okay, so this
minus 0.7, 0.5.
row is right.
Yeah. Maria,
Correct.
do you want
Okay,
me to write it? If it's
yeah, you
difficult?
can write it then. Yeah.
Yeah, looks okay. I hope I can erase what
No,
you
yours is more tidy too, also because people have to understand again.
written. No. I'm not any better. It's okay. So yeah, I've erased it. Let me write it again. Let's go slowly. Are you sure you want to do it here or you want to do it somewhere close to?
No, just start here. No?
Okay. So I'll stop following Maria and I'll ask everyone to follow me. Okay. So I'm starting over here separately. Okay. I am taking the matrix. The matrix is, can we start from, minus 0.7, 0.5,
0.7 minus 0.5
0.7,
minus 0.5.
Minus 1.
right? Okay. Now we know that the equation is taking input xy and giving us output as 0, 0, right? Now, Maria, can you tell me the column view of this
Yeah, x into minus 0.7, 0.7.
X into minus 0.7, 0.7. Okay.
Plus y into 0.5 minus 0.5.
Y into 0.5 minus 0.5. Once you see this, I think, like we solved before, we can solve this very, very quickly. Using the information that we learned that any point on the line, right? So it doesn't matter how I scale the first vector, how I scale the second vector. I can forget the scaling factors. Remember we did this, Maria? I think when we had alpha, remember we did this part? I think I erased that exact part. Nishan was like, don't erase. And I ended up erasing that exact part.
I'm fine. I remember the input. We are multiplying input with alpha and we are getting the output also
Exactly.
multiplied by alpha.
That is the
Yes.
same thing that's happening here, right? What if I take 0.7 out here?
Minus 1, 1.
And I take
You can't write x comma x equal to 0.7 by 0.5, right? Can you write so that is one possible solution.
what is one possible solution?
Let him go step by step. Write down 0.5 y 1 minus 1.
Why am I able to do this?
Same thing we discussed, right? So it's just a scalar quantity getting multiplied to the
Exactly.
column vector.
X is scaling this vector, but this is already scaled by. I am thinking that this is already scaled by. I mean, I just want to take out the
0.7.
scaling factor of 0.7 outside of this.
Right.
So this now this vector still lies on the scaled value of this,
Correct.
right? And
The output of it remains the same. It's on the same line.
exactly. So I'm able to do this. Now can you find very easy x and y's? Or even if you want to do something else, take minus here.
So 0.5 by 0.7 is one solution by 1, but okay. So that's what Ankit was trying to say. Okay.
Write down the. Let us write down the solution now. What after this? What after this?
Yeah. So now I want values for x and y which satisfy this, right? How will I go from here? Okay, and I'm a little confused. So what will I do? I know. Okay, I can do this. 0.7x plus, sorry, minus, let me take minus 0.5y into minus 1, 1 is giving me 0. If there is a and b is equal to 0 and b is non-zero,
then a has to be 0.
A has to be equal to 0. That is nothing but saying vector taking it to the other side, blah blah blah. So I just have to equate this to 0. And when I equate it to 0, I get x is equal to
0.5 by 7.
So this was Maria's question.
I mean, I can
How
write
did
it,
he get
yeah,
that?
yeah, I can write it as a better in the equation of a line. That is better. Y is equal to
this page has become very important.
Could you necessarily say that is the solution?
0.7 by 0.5.
Yeah.
X.
Exactly.
Any point on that line is a solution, right? Yeah.
Sorry?
Any point on that line is a solution to that
Exactly.
metric.
Because you don't have any constant amount in the slope.
Yeah,
So now we understood how we got there, right?
yeah, okay. And so then, yeah, then you have to plug it into the other equation to get the solution, right? The solution that we want.
Yeah. So you want to plug this in what?
X plus y equal to 1000.
Amazing. This is what I wanted. This is where we have concluded the answer, right? If I plug
Then I
in,
think Ankit actually asked like why we're not fitting this equation to the matrix. Generally, when we solve a system, we have to fit all
true,
possible.
true. So that's what I've been suggesting from the start, maybe also. What if I write the third row here? I'm writing it here as 1, 1 equal to x, y, and 1000. You want to try to do that? You want to start? I'll erase this here. Obviously, I don't want it in the middle of nowhere. We can maybe try that. I mean, intuitively, that should also work. That's what I feel. Right? I mean, when we plugged it here, we got x is equal to what? 416, right? Some ... and y is equal to 583. I mean, in a sense, it should be 584 if you want to round off things. Blah, blah, blah. Okay. Now we want to do this entirely with a matrix. Let's try that. So we have 0.3 and 0.7. One thing I see that might be a problem is it loses its sum to 1. Maybe. Let's see if that affects this. Let's see.
That property is lost.
And we don't have an identity. Do we have an identity matrix for a 3 cross 2 matrix?
For that, we have to multiply with the transpose to get something. We cannot directly go from that identity for a rectangular matrices.
Exactly. We need A transpose A. So that might, okay. So that might, okay, let's go. Let's do that, right? That is what we're here for. We want to work with matrices alone. Let's try if that works. So this is 0.5. This is 0.5. This is 1. Input is X and Y. Sorry, it makes it look like there should be 3 inputs. Let me not write like that. X and Y. And the output will be M N, not M and N, sorry. X, Y, and 1000.
But it is not same as x and y.
Yeah, few things that we can see when we start representing it like this, we are losing a few things. One, the matrix columns are not adding to 1 now, so we cannot call it a probability, function, and the output is not equal to the input.
We cannot also solve it in the calculator because calculator offers 3x3 matrix to solve.
But what happens if we take the transpose and multiply? What happens?
Why take transpose?
Do you want to take the transpose and maybe multiply and see what we get? I mean, now we know how to solve the question, at least. Maybe this is a longer way, but maybe this is a way with only matrices, right? We used equations here. Let's see. So if I were to do A transpose A, what would I have to do on the right hand side? Multiply by A transpose, is it? I have to do A transpose here and A transpose here, right?
Yeah, both sides.
Okay, let's try that. So this is A, this is X, this is, oh, I can't call this.
A transpose or A inverse?
Make
Why
it
is
like
multi?
Okay, you want to, okay, what is the inverse of a 3 cross 2 matrix?
2 cross 3. Oh, sorry. Inverse of a 3 cross 2.
No, what is an inverse of a 3 cross 2 matrix, Maria?
I don't know. I'm studying.
There are,
We
when you,
can't directly invert it, right? We directly can't invert it.
yeah,
So
when you look at a 3 cross 2 matrix, what should come to mind? There are 3 equations, but there are only 2 variables,
right,
Yeah.
right.
right? So why are we doing A transpose A?
To make it a square matrix.
So that we get a square matrix. You understand? Because A transpose A is always a square matrix. It's a very, I mean, I haven't seen this proper. I mean, I don't know if it's intuitive or not, but looking at the shape of any matrix, let's say 3 cross 4, right? A transpose A will be 4 cross 3 in multiplied, I mean, matrix multiplication. Let's call it with that function, and 3 cross 4, right?
That will give
Always,
us 4 cross 4.
yeah, it will give us a 4 cross 4.
Yeah, I haven't solved anything like this either. Yeah.
I mean, that's just a general, I mean, it's just, yeah, if you do A transpose A, I mean, that is actually very, very important. Remember, A transpose A comes when we do the perpendicular drop, right? I don't
Oh, yeah.
remember. Yesterday's, yeah, yesterday when sir was explaining.
Many times we were calculating, A transpose A and thing.
Yeah.
This is a really interesting observation to make, it always results to a square matrix.
Yeah, that's,
When it's a variable, you use it the way you like
your voice is a little off. Can you repeat?
I guess when you have a variable or something, it's more useful to do the A transpose calculation because otherwise it just makes it more complicated. Like,
Yeah.
So can I ask one question? What is the what difference does it make for to transpose a matrix? Like we have got an equation, we have written a matrix out of it, and then we make a transpose of it. So what is the physical significance or contextual thing that happens when we do a transpose?
Here, one more thing also, like even if we are making it a square matrix, but still we have a mapping problem that is xy to xy 1000. How should we do that? Because we cannot increase just an arbitrary value in a vector. We cannot introduce it.
Nishan also, yeah, a very good first principle question, right? What does it mean to transpose a matrix?
Yep.
It's a very deep question. I think,
like we are transposing matrix at our convenience. So should we assume that it's making no difference? Or what is the case exactly?
yeah, what's the
maybe we
use
need
of
to understand.
transposing a matrix?
Like
Yeah.
we can, till now we haven't drawn the this indices in that were present in the row. Like we were drawing in the vectors in the column space, column vectors. But after transposing, it is feasible. So that thing is quite odd if you see. So,
Now, feasibility is well understood. The question is, does changing rows by columns?
Very good
Bring-
question. Very good question. Yeah, very relevant question as well. What I feel is maybe we should discuss row spaces and column spaces before we go there, and the relation between row spaces and column spaces, because what actually is happening in a transfer. I mean, when you transpose a matrix, is you are exchanging the row space and the column space.
Yeah, that
So
I
if you know, yeah,
I
yeah.
get,
So if,
but when we are doing the row space, now we are considering these variables, that is x, y, z, whatever that is present. But in the vector, that is column vector picture, we are not considering the variables. We are just
we are. It's just hidden, right? Because the first line of every equation is actually the row. I mean, think about it, right? The first entry is being multiplied by each variable and being summed up. It's a linear combination of them, which also happens in the row space. It's not, it's just a different view of the data, yes, but it's not changing anything, right? It's, I mean, yeah, it's hard to, because we've tried to, I mean, once we see the column picture, it actually gives us a different idea. Oh, take a vector, scale it, add it with another scale vector. When you think about it like that, it's actually very easy. But when you try to compare the row space and column space,
So how do you visualize this row space?
how do we visualize the row space?
It will represent a row space would represent
Yeah.
a row space would represent a space, you know, a span of line. So
Think about it like this. Okay. Okay. When I look at column, I know I'm taking a vector. Let me go slowly. It's a very tricky concept as well. When I look at a column of a vector, let's say there's just one column vector, right? I know. Okay, what is the? Let's say this is a. Actually, we'll take an example. Why take abstract? I'm taking a column of 1, 2. It is telling me this vector lies 1 unit in x direction, 2 units in y direction, and I can scale this up and down how much ever I want. Right? Right? If I look at the row space,
But
right?
here the thing to consider is the context in which we are using x and y is different, in which we are using the equations in.
Sorry, can you repeat that? What do you mean?
What I am saying is, for like we are writing 1x plus 3y is equal to some constant.
Okay, maybe you want to use a different.
No, he is saying that we are
Yeah.
representing.
Those are just
when-
variables, right? So those are just variables. This is
Just make them I cap, J cap, just to differentiate.
Yeah, I think this is why I cap and J cap also came. So we also found a reason why I cap and J cap exist.
No. If we are going to, you know, take a transpose of it and make a physical significance out of it, or make a sense out of it, what we can say is that when we write 1, 2 in column, it represents a vector. Fine. So what will, if we write 1, 2 in a row, then it should represent a vector. That is the change we can perceive, and nothing changes in that case, isn't it?
So you're saying if I see 1, 3 as a vector, is that
he
what you're
is-
trying to do?
If we start seeing 1, 3 as a vector, then it makes
We
no.
cannot see as a unique vector because 1 has a scaling factor of x and 3 has a scaling factor of y. So they should not be unique. We cannot associate them directly. That's why we have to get
we
the
take column
underlying.
picture.
If the scaling factor was same, then we definitely can see the vector.
Scaling factor being x and y, isn't it?
Yeah, means if you want to consider it a single entity, then they should share something common, not something that is different.
You mean x and y, either x or y, isn't it?
Yeah, yeah. In that case, we can definitely consider it. The only solution to the raw picture means or just see the equation alternate ways, finding the intercept and drawing the line or the plane that it enters in that space. So here it is a line because two variables. So only finding the intercept we can draw alternate picture. Now,
Let us finish this concept and be done for the day, maybe, because it's clock is ticking to almost ticking to 10 minutes to.
What is the first row telling me? Oh my god, it's still being recorded, is it?
yeah,
The video? Oh my god, isn't
yeah,
that too long? Maybe you
yeah.
should stop also. I think now I am not I am just even I am trying to figure out also. So it's not like I don't think it's easy to look at row space.
I don't think